state, ma. So in solid state, see ma, how the atoms are arranged and each atom is touching with how many atoms. This is the most important discussion that we have to study in this topic. Okay, ma? Where is the position of the atom? Where atom is present? Okay, and it is touching with how many atoms? This is the most important discussion. So once you understand this one, so total solid state is dependent on this discussion only. Okay, so first of all we will study about crystal lattice. Okay, ma? Crystal lattice. So first of all, solids you can divide into two types, no, ma? Okay, solids you can divide into two types. One is crystalline solids, second one is amorphous solids. Are you able to understand? So what is meant by crystalline solid and what is the difference between crystalline solids and amorphous solids? Difference in Chapandi, 12th class students, you can say this one. Clear? Crystalline solids means atoms are arranged in a particular fashion. Okay, ma? So there is particular sequence in which atoms are arranged. That type of arrangement, what you call, the type of solids, you can call them as crystalline solids. Are you able to understand? NaCl and other molecules, you can call them as crystalline solids. Then what is meant by amorphous solids, ma? Okay. So no regular arrangement of solids or atoms or molecules. This is called as amorphous solids. For example, glass. In glass, the molecules, they are not present in a particular fashion, no, ma? Wax. Wax is an example. In wax, the molecules, they are not arranged in a particular fashion. So that type of solids, you can call them as amorphous solids, and the solids in which there is a particular arrangement, that is called as crystalline solids. Okay. Now the question is, what is meant by crystal lattice? Crystal lattice means what? The arrangement of, okay, ma? Arrangement of atoms in a sequence or in a fashion. That is called as crystal lattice. Are you able to understand? And there are many types of crystal lattices, ma. So cubical lattices are present, hexagonal lattices are present, parallelogram type of lattices are present, triagonal lattices are present, tetrahedral lattices are present. There are many types of lattices. Are you able to understand? Lattices means what? The arrangement of atoms in a particular fashion is nothing but lattice. In a crystal, atoms are arranged in a particular fashion. No? That fashion of arrangement is nothing but crystal lattice. Are you able to understand? For example, you can take this kind of arrangement. Okay. Are you able to understand, ma? So, arrangement, if it is like this. So, this type of arrangement is possible, no? Are you able to understand? So, just the arrangement of all the atoms in a particular structure or in a particular sequence, that is called as crystal lattice. Are you able to understand? And after crystal lattice, we study about a very important term which is called as unit cell. Okay, so what is meant by unit cell here? Unit cell is, I will write the definition here. So the smallest arrangement of atoms, clear, ma? Which repeats itself and thus, clear, ma? A crystal lattice will be formed. So that type of arrangement is called as unit cell. Now can you say what is meant by unit cell, ma? So by looking at this definition, what you have understood? Unit cell and time cheppandi. Unit cell means it is the smallest group of atoms or smallest arrangement of atoms which repeats itself continuously, so that finally a crystal lattice is formed. Are you able to understand? For example, consider there is some group of atoms which are arranged like this. Are you able to understand more? In this one, which is the unit cell, can you say? So consider atoms are arranged like this. So these points are only atoms. So in this group of arrangement, which is the unit cell? Indulo unit cell edi cheppandi. So you can say this one is one unit cell, no? This I can call it as one unit cell. Are you able to understand? Or each of them also you can call it as a unit cell. Why? So this type of cells, they are continuously arranged, no? So smallest arrangement which repeats itself, that is called as a unit cell. And the shape of unit cell can be anything. It can be square also, it can be triangular also, it can be rectangular also, tetrahedral also, polygon also, whatever may be the shape of the unit lattice. It should repeat itself so that crystal lattice will be formed. Are you able to understand? For example, in this room, if you see, there are how many benches? 4 rows in one bench, and here also there are 4 rows in one bench. No? So each bench is called a unit cell because it is repeating itself. No? Are you able to understand? No? Instead of that, I will do one thing. I will place one iron bench and I will place one wooden bench. Then that sequence, in that sequence, which is the unit cell? ఒక ఐరన్ బెంచ్, తర్వాత ఒక వుడన్ బెంచ్, ఆ తర్వాత ఒక ఐరన్ బెంచ్, మళ్ళీ ఒక వుడన్ బెంచ్. ఇన్ దట్ వన్ విచ్ ఇస్ ద యూనిట్ సెల్? ఏ గ్రూప్ ఆఫ్ ఐరన్ బెంచ్ అండ్ ఏ గ్రూప్ ఆఫ్ వుడ్ బెంచ్. సో బోత్ ఆఫ్ దెమ్ మేక్ వన్ యూనిట్ సెల్. అర్థమవుతుంది కదా? రెండు కలిపి ఒక యూనిట్ సెల్ని తయారు చేస్తారు బికాస్ దట్ రిపీషన్ ఈస్ రిపీటెడ్ కంటిన్యూస్లీ. సో యూనిట్ సెల్ మీన్స్ స్మాలెస్ట్ అరేంజ్మెంట్ ఆఫ్ సెల్స్ which if you repeat them continuously, finally crystal lattice should be formed. That is called as a unit cell. Are you able to understand? And we limit our discussion only up to cubic unit cells. Manam discussion enta varaku limit chestam ee class lo? Only up to cubic unit cell. What is meant by cubic unit cell? Cubic unit cell means which is present in the form of a cube. That is called as a cubic unit cell, no? Okay. So this is the cubic unit cell, where atoms may be present at corners, atoms may be present at the edges, atoms may be present on the faces, atoms may be present at the center of this cubic cell also. Are you able to understand? No? So we are limiting our discussion only up to cubic unit cell. Are you able to understand? So right now. So therefore what we write? We limit our discussion up to what? Up to cubic unit cell. Okay ma? So cubic unit cell means how many corners are there, can you say? Cubic unit cell lo corners ennu untayi cheppandi. How many corners will be there? 8 corners will be there. How many faces will be there? 6 faces will be there. Clear na ma? See here. So this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. 8 corners are present. Are you able to understand? Faces, how many faces? So this is first face, this is second face, and these 2 faces, they are covered by another 4 faces. Cube ki 4 faces untayi, ee vaipu malli 2 faces untayi. So totally how many faces? 6 faces are present. Are you able to understand ma? So therefore cube has 8 corners and 6 faces. So this is called as a cube now, and we are limiting our discussion only up to cube only. So here length of the cube is A, breadth of the cube is A, thickness of the cube is also A only. Are you able to understand? No? And angle between any 2 edges is how much? 90 degrees. So we are studying only that type of units. Rendu edges madhyalo angle 90 degrees untundi kada? Are you able to understand? No? So therefore I can say any angle is how much? It is equal to 90 degrees. Okay. So therefore what is the volume of this unit cell ma? Volume of unit cell will be how much? Cheppandi. Volume of unit cell, a cube, volume of a cube is a cube only, no? If length is A, breadth is A, and depth is also A, then volume of this unit cell is A. Are you able to understand? We are discussing about this one. Now we will study about types of unit cells ma? How many types of unit cells are possible, and we will study each of them in detail. Okay. So types of unit cell. Okay. So first one is primitive unit cell. Okay, ma? Primitive unit cell. Second one you can call it as FCC, face centered cubic. Write the full form of this one. Face centered cubic unit cell. And one more type is BCC. BCC means what? Body centered cubic cell. And one more type is ECC. ECC means what? End centered cubic cell. Okay, so these are the four types of unit cells which we will study. Are you able to understand, ma? First one is called what? First one is called as primitive unit cell, and FCC, BCC and ECC. So these are the types of unit cells which we will study. Okay, so let us have our discussion on the first one, which is called as primitive unit cell. Okay, so write down now. We are discussing about what now? We are discussing about primitive unit cell. So write the side heading, primitive unit cell. Okay, so here atoms are present only at the corners itself. Okay, ma? So in this primitive unit cell, where atoms are present? Atoms are present only at the corners. How many corners are there? 8 corners. So how many atoms will be there in this primitive unit cell? 8 atoms will be there. Are you able to understand? So shall we draw the diagram of this one? So how this one will be, Seema? So let us draw this cube first of all. This one. So here there will be one cell, one atom. Here there will be one atom. Here there will be one atom. Here there will be one atom. Another atom, another atom, another atom and another atom. So totally how many atoms? 8 atoms are present. So this is called as a primitive unit cell, where atoms, they are present only at the corners only. They are not present at edges. They are not present on the face. They are not present at the center also. That is called as a primitive unit cell. Clear, ma? So next important point is okay. Second point is the corner atoms, okay, ma? They touch together. Okay, ma? What about the corner atoms? These are the corner atoms, no? So corner atoms, they always touch with each other, or we can say they are very close to each other. And this is the specialty of only primitive cell. In other cells, the corner atoms, they never touch. ఈ పాయింట్ మనం మర్చిపోకూడదు. అర్థమవుతుంది కదా? సో ఓన్లీ ఇన్ విచ్ సెల్? ఓన్లీ ఇన్ primitive cell only this is possible. Only in primitive cell only the atoms, which atoms? Corner atoms, they will touch with each other. So what is the meaning of this one, Seema? So here there is one atom, no? Actually this is not how atoms are arranged. Atoms, they are arranged like this. Are you able to understand? So this atom is in contact with the next atom. Okay? Similarly this atom is in contact with the next atom like this. It means the atoms which are present at the corners, they will be touching with each other. And this is the property of only primitive cell. In other cells, corner atoms will never touch each other. Are you able to understand now? Third point is that the atoms of face diagonal do not touch each other. Do not touch each other. Okay, ma? So at the starting of the topic only I have said, ma, where atom is present and it is a touching with what? So ప్రతి యూనిట్స్లోనూ ఇదే మనం గమనించాల్సింది. ఆటమ్స్ ఎక్కడ ఉన్నాయి, ఎవరిని టచ్ చేస్తున్నాయి. Then our discussion, half of our solid state is completed. Are you able to understand, ma? So atoms which are present at the face diagonal, they do not touch with each other. Now can you say what is meant by face diagonal? Ma? In this unit cell, in this cube, what is meant by face diagonal? Face diagonal ante? Face means what? So this is one face, no? This is one face. 6 faces are there, no? Ma? So this is one face, top face. So diagonal means what? Connecting one atom to another atom exactly in opposite direction along the diagonal. This is called as a face diagonal. So this atom and this atom, they are not touching with each other. Are you able to understand? Ma? Only corner atoms, they will touch with each other. These atoms, they will never touch with each other. Another point. Okay, ma? Fourth point is that the atoms of body diagonal, atoms of body diagonal do not touch each other. Okay? So the atoms which are present on the face diagonal also, they will not touch. Similarly, the atoms which are present on the body diagonal also, they will not touch. Now can you say, in this primitive unit cell, what is meant by body diagonal? Body diagonal ante cheppandi. Let us name this one as 1, 2, 3, 4, 5, 6, 7, 8. So draw a body line means which atom and which atom you will touch? 1 and 1 and no 1. Very good. 1 and 7 you can touch. Sima, this atom, it is present out of the board, no? Sima, here which atoms are present outside the board and which atoms are present inside the board? 1, 4, 8, 5. They are present out of the board. That's all, no? And which atoms are present inside the board? 2, 3, 6, 7. They are present inside the board. Are you able to understand? So you have to draw a diagonal from one atom which is present inside the board to the topmost corner of that atom which is present out of the board. That is called as body diagonal. అర్థమవుతుంది కదా? సో ఏ ఆటమ్కి డ్రా చేయాలి కనెక్షన్? మీరు బోర్డు లోపల ఉన్న ఒక ఆటము లోయెస్ట్ పొజిషన్ దగ్గర ఉన్నది, బోర్డు బయట ఇంకొక ఆటం ఉంటుంది కదా, అది ఎక్కడ హైయెస్ట్ పొజిషన్లో ఉండాలి. సో దోస్ టూ ఆటమ్స్ ఇఫ్ యూ కనెక్ట్, దట్ diagonal is called as body diagonal. Are you able to understand? So therefore, now see which one and which one? 1 and 7. This is out of board number, and 7 is present inside the board. Correct only, no? So therefore, this diagonal is called as body diagonal. So like this you can draw 4 diagonals. Are you able to understand, ma? So therefore, the atoms which are present on the body diagonal also, they do not touch with each other. So these are the properties of primitive cell. Are you able to understand, ma? Come on, make a note up to here, then we will do some calculations. This total discussion we are doing for which cell? We are doing for primitive unit cell. Okay, primitive unit cell. So in each of these unit cells we will discuss 4 concepts, clear, which are very important. And which is the first concept we are discussing? The number of atoms by mass enclosed by one unit cell. Okay, see, at each corner there is one atom, no? ఒక్కొక్క కార్నర్ దగ్గర ఒక్కొక్క atom ఉంది. So finally, this primitive unit cell is enclosing how many atoms by mass? Are you able to understand? See, so here there is one atom. Are you able to understand, ma? Here there is one atom, here there is one atom, here there is one atom, here another one, here another one, here another one, here another one. All these atoms, are they enclosed by this unit cell? అన్ని atoms ని ఇది enclose చేస్తుందా? Primitive unit cell, is it enclosing all the atoms? No, it is enclosing only part of atoms. ఒక పార్ట్ని మాత్రమే ఎంక్లోజ్ చేస్తుంది. Are you able to understand, ma? So ఆ పార్ట్స్ అన్ని యాడ్ చేసుకుంటూ వెళితే, if you add all those parts, finally this primitive unit cell is covering how many atoms by mass? That I want to calculate. అర్థమవుతుంది కదా? See, ma, for example, if there is one atom which is present at the corner, there is one atom which is present at the corner, that corner atom can touch how many primitive unit cells? Can you say? So this is a primitive unit cell, no? There is one atom at corner. So this corner atom, it can be in contact with how many primitive unit cells? ఎన్ని primitive unit cells లో అది కాంటాక్ట్ లో ఉండగలదు?
1/8.
8 unit cells. It can be in contact with 8 unit cells. ఎలా చూద్దాం చూడండి. మళ్ళీ ఒక అద్భుతమైన డయాగ్రామ్ వేస్తాను. సేమ్. సో దిస్ ఈజ్ వన్ యూనిట్ సెల్. దిస్ ఈజ్ అనదర్ యూనిట్ సెల్. క్లియర్ నమ్మా? సో దిస్ ఈజ్ అనదర్ యూనిట్ సెల్. దిస్ ఈజ్ అనదర్ యూనిట్ సెల్. 4 unit cells are present. Are you able to understand? And at the corner there is one atom, Nama. At the corner there is one atom. This atom, it is touching all the 4 unit cells, no? But I can say that only half of the atom is touching 4 of them. So on this primitive unit cells, again I can place one more 4 unit cells, no? Half of the atom touches the above 4 unit cells, and lower half of the atom touches lowermost part of 4 unit cells. Atom ni rendu bhagalu chesinaru anukondi. If you make atom into 2 parts, upper part is touching 4 unit cells, lower part is also touching 4 unit cells. Are you able to understand? So this corner atom, it can touch how many unit cells ma? 8 unit cells it can touch. Artham avutundi kada? We are taking 4 primitive atoms, and only at the corner half matrame touch avutuntayi kada avi. Remaining half ni ఆ 4 primitive cells పైన మళ్ళీ 4 primitive cells ప్లేస్ చేయాలి మనం. సో హాఫ్ ఆఫ్ ద ఆటమ్ ఇస్ కవర్డ్ బై బాటమ్ 4, అబౌవ్ హాఫ్ ఆఫ్ ద ఆటమ్ ఇస్ కవర్డ్ బై టాప్ 4. ఓకే. సో వెన్ అన్ ఆటమ్ ఈస్ ప్రెసెంట్ అట్ ద కార్నర్, దెన్ దిస్ కార్నర్ ఆటమ్ కెన్ టచ్ 8 primitive cells. సో దిస్ ఈజ్ అ వెరీ ఇంపార్టెంట్ డిస్కషన్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? క్యూబ్స్ ఉంటే మనం చూపించి ఉండొచ్చు. ఇస్ ఇట్ క్లియర్ వాట్ ఈస్ హ్యాపెనింగ్? దీస్ ఆర్ 4 primitive cells మా. వాటిపైన మళ్ళీ 4 cells ప్లేస్ చేసినాం అనుకోండి. ఇంకా ఈ ఆటమ్ ఎక్కడ ఉంటుంది? దిస్ ఆటమ్ విల్ బి ఎగ్జాక్ట్లీ అట్ ద మిడిల్. 8 క్యూబ్స్ మధ్యలో ఉంటుంది. అంటే 8 టచ్ చేస్తూ ఉంది కదా. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? వీఆర్ ప్లేసింగ్ 8 atoms అండ్ దిస్ ఈస్ ఎగ్జాక్ట్లీ అట్ ద మిడిల్. సో ఇట్ ఈస్ టచింగ్ బాటమ్ 4 ఆల్సో, ఇట్ ఈస్ టచింగ్ టాప్ 4 ఆల్సో. సో దేర్ ఫోర్ ఈచ్ కార్నర్ ఆటమ్ కెన్ టచ్ 8 primitive cells. దిస్ ఈస్ వన్ డిస్కషన్. ఓకే. సో మేక్ ఎ నోట్ ఆఫ్ ఇట్. సో ఈచ్ కార్నర్ atom, corner means this one, clear? This one, all of them, they are corners. Each corner atom can touch 8 primitive unit cells. Okay. Therefore, in each unit cell, how much mass of atom will be present? 1/8 only, no? So its total mass is distributed in 8 unit cells. 8 unit cells లో దాని మాస్ డిస్ట్రిబ్యూట్ అయి ఉంటుంది. దెన్ ఈచ్ atom will have 1/8 of the unit cell. Are you able to understand? So therefore we write each unit cell will have 1/8 mass of each atom. Are you able to understand? For each atom, totally how many atoms are there in a primitive unit cell? 8 atoms are there because 8 corners are there. In each atom, 1/8 of mass is only present in one primitive cell. So how many atoms totally? 8 atoms. 8 into 1/8? 8 into 1/8? 1. So only 1 atomic mass is present in a primitive unit cell. By mass. Mass prakaram తీసుకుంటే 8 atoms are there, no? And each atom contributes only 1/8 mass. Total how many atoms are there? 8 atoms are there. So 8 into 1/8? Only 1. Are you able to understand? So like this. Let us do one more calculation. Now this is discussion about corners. Okay ma? Now if atoms they are present at edges. Okay. What is meant by edge ma? So this is a cube and one atom is present at one edge. Okay. Then this atom can touch how many cells? 4 cells. Are you able to understand? It can touch only 4 cells, no ma? So దాని పక్కన ఒక సెల్ ఉంటుంది. Here there is one more cell. So it is touching total how many cells? 2 cells. Clear, no? And above these 2 cells I place one more 2 cells. Then it will be totally surrounded, no? Are you able to understand, no? So when atom is present at the edges, then that cell can touch 4 primitive unit cells. అర్థమవుతుందా? క్యూబ్ లాంటి బాడీ ఏదన్నా ఉందా ఇక్కడ? క్యూబ్ లాంటి బాడీ ఏది లేదు. ఓకేమా? సో దేర్ ఫోర్ అబ్బా వద్దులేరా బాబు. ఓకేమా? So each edge atom can touch 4 unit cells. How many cells it can touch, ma? It can touch 4 unit cells. Okay. So therefore, how much mass will be present in each unit cell if atom is present at edges? 1 by 4. 1 by 4. Ante kada? So therefore, each unit cell will have 1 by 4th mass of each atom. Are you able to understand? Okay, ma? Next discussion. So, atom is present at the face. Where atom is present, ma? So, this is one unit cell. Okay, ma? This is one unit cell, ma? So, atom, where atom is present, this is one face, no? Atom is present on the face. Face pain undi. It is not present at the middle. It is present on the face. For example, this is the topmost face, no? So, one atom is present at the topmost face. Then this atom can touch how many unit cells? 2. Only 2 unit cells. Are you able to understand, no? So, half of the atom is present in this unit cell. Danipan inkokati place chestunnaru anukondi. On that unit cell, if you place one more cell, it will be completely surrounded, no? Purtiga surround ayipotundi kada. So, when atom is present at the face, then this atom can touch only 2 unit cells. Okay, so therefore I know. So each face, are you able to understand what is meant by face, ma? Face means, so consider this is a cuboid, so it will have 6 faces, no? 1, 2, 3, 4, 5, 6 faces. Atom is present on the topmost position. This is the face. Are you able to understand? So, this battery pan inko battery place chestunnaru anukondi. Now it is touching only 2 unit cells. No? That's the meaning of it. Okay? Okay. Understood now? So therefore, when atom is present on one face, then each face touches how many primitive cells, ma? 2 primitive cubic cells. Are you able to understand? Therefore, how much mass is present in 1 by 2? Therefore, half mass of atom is present in each unit cell. Each unit cell will cover how much percentage of mass? 50%. It means only half of the atom is present in one primitive cell, another half is present in another primitive cell. Are you able to understand what is happening here? That's it. So therefore, this discussion is the most important discussion. When atom is present at corner, then that primitive cell will enclose only 1 by 8th mass. When atom is present at edges, then that primitive cell will enclose only 1 by 4th mass. When atom is present at the face, then it will enclose only half of the mass. Okay? Now similarly, when atom is present at center of the primitive cell, then center, only one, no? Okay, ma? So atom at center of primitive cell. Okay, then one atom is completely present inside unit cell. Are you able to understand, ma? Now where is the atom? Atom is present exactly at the middle of the cell. Then that one will touch only one primitive cell. మధ్యలో ఉంది కాబట్టి ఒక దాంట్లోనే ఉంటుంది. ఇదే ఒక క్యూబ్ అనుకోండి, రూమ్ మధ్యలో ఉన్నారు మీరు. ఎన్ని సెల్స్ని టచ్ చేస్తారు? మర్యాద ఒకదాన్నే టచ్ చేస్తారు, బికాస్ యు ఆర్ ప్రెసెంట్ ఇన్సైడ్ ద సెల్. ఓకే, దేర్ ఫోర్ టోటల్ మాస్ ఈస్ ఎన్క్లోజ్డ్ బై one primitive cell. Are you able to understand, ma? Therefore, for any type of cell, the formula to calculate the number of atoms is this one. So, number of atoms by mass in any cubic cell. Which is the formula, ma? So, number of corner atoms divided by what? Corner atoms lo enta part untundi? 8th part only. That's all, no? If there is one corner atom, 1 by 8. 8 corner atoms, 8 by 8, like this. Are you able to understand? Because each corner atom will give only 1 by 8th of this mass inside the primitive cell. 1 by 8th mass మాత్రమే ఉంటుంది కదా దాంట్లో. Clear ma? Similarly, number of atoms present at edges divided by 4. Number of atoms present at face divided by 2. Number of atoms present at center divided by 1. This is the formula. Student, the beautiful ga undi formula. Clear nama? Now we do the calculation for primitive unit cell. ఇప్పుడు మనము primitive unit cell గురించి మాట్లాడదాం. Okay ma? So for primitive unit cell, how many atoms are present? 8. Where they are present? Only at the corners only. Edges lo levu, face lo ledu, center lo ledu. Are you able to understand ma? So therefore, number of atoms, how can I calculate? Number of atoms by mass is equals to number of atoms in corners is 8 by 8 plus number of atoms at edges 0 by 4, number of atoms at face 0 by 2, number of corners at center 0 by 1. Okay ma? So 8 by 8 is how much? 1 atom. That is my answer. Understood ma? So therefore primitive unit cell will cover only 1 atom of mass inside its volume. తన వాల్యూమ్లో ఒక atomని మాత్రమే ఉంచినట్టు లెక్క. ఓకే, యాక్చువల్లీ ఇట్ ఈస్ ఎన్క్లోజింగ్ పార్షియలీ 8 atoms, బట్ బై మాస్ రేషియో ఇట్ ఈస్ ఎన్క్లోజింగ్ ఓన్లీ 1 atom. ఓకే, సో దిస్ ఈస్ ద మోస్ట్ ఇంపార్టెంట్ డిస్కషన్ ఇన్ సో ద నెంబర్ ఆఫ్ atoms ఎన్క్లోజ్డ్ బై ఎనీ కైండ్ ఆఫ్ ప్రిమిటివ్ సెల్. ఇక దేనికైనా ఇదే ఫార్ములానే మీరు వాడుకుంటే సరిపోతుంది. Are you able to understand? That's it. Okay. So, okay ma? So we will stop our discussion up to here. We will continue in the next class. This was what we have studied until the last class. Once revise it briefly ma. So primitive unit cell means what? Cells, they are present only at the corners. How many corners are there? 8 corners are there, so 8 cells will be present. And these corner atoms, they will be touching with each other. So this corner atom touches with this one, this corner atom touches with this one, this corner atom touches with this one. So all the corner atoms which are present on the same edge, they will be touching with each other. Are you able to understand ma? So therefore, first concept what we have studied, number of atoms enclosed by unit cell by mass. Okay ma? So this unit cell will enclose how many atoms by concept of their mass. Then this was the equation which we have used, you know, n corner divided by 8, n edge divided by 4, n face divided by 2, and n center divided by 1. This is what we have studied. Okay ma? So then we study the second concept number 2, which says that relation between, okay ma, relation between atomic radius and edge length. Okay, so that relation we are going to derive now. So these relations, they are very important ma, because many times direct questions will be asked in them. 2015, 2021, are able to understand? 2019, 2004, 2006 also questions were asked from this concept. So relation between what? Relation between atomic radius and edge length. Okay, so let us draw this primitive unit cell first of all. Clear no ma? So this is the unit cell no ma? Okay, so what is the shape of this figure which we are drawing? This is a cubical shape, no? Cubical shape means what? Length, breadth and height, everything will be equal to what? Everything will be equal to A only. That is called as a cube no ma? So therefore volume of this cube is a cube. Okay, now let us see. So here let us take 2 corner atoms. Here there is one atom and here there is one more atom. Are you able to understand ma? So let us draw, this is one atom. Are you able to understand ma? and this is one more atom. So these two atoms, they are touching like this. So already we discussed that in primitive unit cell, corner atoms, they will touch with each other. This is what we have studied now. Okay, now see. So therefore, can you say what is this distance, ma? What is this? Let us call this point as point number 1 and this point as point number 2. So distance between, okay, 1 and 2 is how much? Can you say? Distance between 1 and 2 is how much? A only, no? A is nothing but edge length. So this is equal to A. Can I say? And this A is also equal to, this distance is R, no ma? Radius of this atom is R. Radius of one more atom is another R. So A is also equal to 2R. I can write like this, no? So this is the relation between edge length and radius of the atom. In the case of which kind of atom? In the case of primitive cell. Are you able to understand? So edge length A is exactly equal to 2 times the radius of the single atom. Are you able to understand? Okay. So next concept which we write is distance between nearest atoms. So let us call it as point number I or 1. Okay, ma? Can you say what is the distance between nearest atoms, ma? Which two atoms are nearest atoms in this primitive cell? Totally 8 atoms are present, no? In out of these two atoms, which are the two atoms which are very close to each other? Huh? Definitely the atoms which are touching with each other, they are close to each other, no? ఏ ఆటమ్స్ అయితే టచ్ అవుతూ ఉంటాయో అంతకంటే క్లోజ్ ఇంకేముంటుంది, ఇంకా ఒక ఆటం ఇంకో దాంట్లోకి దూరి వెళ్ళిపోలేదు కదా. వన్ ఆటమ్ కెనాట్ ఎంటర్ ఇంటూ అనదర్ ఆటమ్, నో? సో డెఫినెట్లీ దట్ డిస్టెన్స్ between two atoms which are touching with each other, that should be the least distance. Adhe kada least distance. Okay. Now these two atoms, are they touching? Touch avutu unnai kada. So that is the least distance. So that is nothing but A. Can I write? In terms of edge length, if I write, then that distance is nothing but A. Clear, no ma? Okay. Next, see. So second question which can be asked is that next to nearest distance. Next to nearest distance. Okay. It means which is that distance which is slightly greater than smallest distance. Distance between two atoms I am discussing. Are you able to understand? What is this one? Distance between two nearest atoms. This is also next to nearest distance between two atoms. Okay. So nearest distance already we have calculated. Next nearest distance, దాని తర్వాత nearest ఏదవుతుంది? Opposite means face diagonal or body diagonal? Sima, let us call this is 1 point. Okay, point number 1. This is 2. This is 3. Okay, and this one let us call it as 5th point. This point is point number 5. Okay. So if I draw line between 1 and 3, 1 ki 3 ki line draw cheste, will it become face diagonal or body diagonal? That is face diagonal, no? Are you able to understand, no ma? So 1, 2, 3, 4, these 4 points, they are the points present on single face. Oka face pain unnai kada avi. So if I take a distance between 1 and 3, that is face diagonal. Okay. So after traveling this distance between 1 and 2 is the least distance. Next least distance is definitely distance between 1 and 3 only. Are you able to understand, Amma? So therefore, next to nearest distance is what? Next to nearest distance is, it is nothing but distance between which and which, ma? 1 and 3. Okay. Distance between 1 and 3, because both of them they are present on the same face. The next nearest adi ayi untundi kada, cube edama meeru techindi, give me the cube. Okay. Now see ma. So where is point number 1? This is point number 1. Okay. Point number 2, point number 3, point number 4. All of them they are present on the same face, no? First nearest distance is distance between these two, 1 and 2. Are you able to understand, ma? Next nearest distance must be between 1 and this, which is this point, 3 point. 1 and 3. So is it face diagonal or body diagonal? Face diagonal. Then which is body diagonal? If I take this point and this point, then they become body diagonal. Are you able to understand? And that is not the next nearest distance. So next nearest distance is definitely distance between 1 and 3 only. So which is called as face diagonal. Okay. Now can you say what is the length of a face diagonal? For example, if I draw this face, which face? So 1, 2, 3, 4. 1, 2, 3, 4 face I am drawing. This is the topmost face. Pine nunchi chuste naku ee face e kada kaniపించేది, and that is that face. 1, 2, 3, 4 face. Okay. Now in that 1, 2, 3, 4 face, this is the distance which I am taking, no? Okay ma? Now can you say how much will be this distance? Our distance ఎంత ఉంటుంది చెప్పండి? Root 2a, that's all. Root 2a only, no? Because distance between 1 and 2 is a. Distance between 2 and 3 is also a. Edge length a ne kada undedi. Then this becomes hypotenuse, no ma? Then hypotenuse value is equals to how much? Square root of a square plus a square is root 2 into a. Okay ma? So therefore this distance is the next to nearest distance. Are you able to understand? Okay. Third point. Third point is next to nearest distance. Now can you say what is this one? అంటే దీనికన్నా కొంచెం ఎక్కువ ఉండాలి. The distance which is slightly greater than next to next. And what is that one? That is definitely body diagonal. Are you able to understand, Nama? So or I can say distance between 1 and 5. Okay. So see in this figure, here there is point number 1. ఇక్కడ ఉంది point number 1. And where is point number 5? Point number 5 is present here. Okay. So can you say what will be this distance? ఈ distance ఎంత ఉంటుంది చెప్పండి? వెక్టర్స్లో చదివాం కదా మనం. This distance will be root 3a. Our distance ఎంత ఉంటుంది? Root 3a. Because in traveling from first point to fifth point, I have to travel one length, one width and one height also. Clear now? So square root of a square plus a square plus a square, root 3 into a. Okay, so next to next distance is what here? Distance between which point and which point? First point and fifth point. Clear nama? First point is present inside the board. Board lopal undi kada adi. Fifth point is present outside the board. Are you able to understand? So that distance will be how much? And that is equals to body diagonal. Okay. And that distance will be root 3 into a. Understood now how we are calculating the distances? Distances paina clarity vachindi kadama? Clear no? So already we have discussed nama where the atoms are present and atoms are touching what? Evarni touch chestunnai. This is the most important discussion in the case of primitive cells. Are you able to understand? Okay. So second concept we have completed, no? Next let us go to the third one. Okay. See here this point you should remember. 1. What is meant by 1 here? Primitive unit cell will cover how many atoms by mass? 1 atom. Primitive unit cell will cover only 1 atom by mass. Because every corner atom, it will contribute how much percentage of mass? 1 by 8th of the mass. Total 8 atoms are there, no? 8 into 1 by 8, 1 atom only. Total it is covered by a primitive unit cell. Is it clear? That's it. Okay. Third concept. Third concept is coordination number. Okay, ma? So concept number 3. Okay, coordination number. Okay, what is meant by coordination number? So the number of atoms surrounded with shortest distance. Number of atoms surrounded with shortest distance. For example, if I take any one atom, are you able to understand ma? That atom is surrounded by how many atoms which are present at the least distance? That number is called as coordination number. And ma, we don't try to understand this one, just you try to just by heart, that is better. Are you able to understand? Because you can never find any lattice structure in the examination, no? పట్టుకొని కౌంట్ చేసుకుంటూ కూర్చోవాలంటే అయ్యే పని కాదు. సో యూ బై హార్ట్. క్లియర్ అమ్మా? సో ఐఎమ్ రైటింగ్ దిస్ details here. For primitive cubic cell, PCC means primitive cubic cell, coordination number is how much? It is 6. It means each atom will be surrounded by how many atoms? 6 atoms which are present at the shortest distance. Are you able to understand? And for BCC means what? Body centered cubic unit cell. Okay ma? For this one the coordination number will be 8. Okay? And for FCC, face centered cubic unit cell, it will be 12. Okay ma? So by heart these 3 values, so that will be always useful for you. Are you able to understand? So therefore coordination number for a primitive unit cell is 6. For BCC, body centered cubic cell, is 8. And for a face centered cubic cell it is 12. Understood now? These values you should by heart. Okay? Next concept, fourth one. Fourth concept is packing fraction. Packing fraction. Okay ma? It indicates how much percent of unit cell is occupied. Okay ma? And how much percent it is empty. Empty technical term is void. Are you able to understand ma? So packing fraction then indicates packing fraction indicates that how much percentage of the unit cell is filled with atoms and how much percentage it is empty. That fraction we can call it as packing fraction. Are you able to understand ma? So therefore, how can I write the equation for packing fraction? I can write like this. Okay ma? So volume occupied by atoms by mass divided by total volume of unit cell. Total volume of unit cell. Are you able to understand ma? So for example, if one atom is present, so you write one atom volume divided by what is the volume of a unit cell. Then you will get a fractional volume, no? That fraction is nothing but packing fraction. Are you able to understand ma? So for example, if you take PCC, primitive unit cell, only one atom is there, no? So you write the volume of that atom divided by what is the volume of the unit cell. That fraction will give packing fraction. Are you able to understand? So same equation I can write like this also. How I can write? Sima. I can also write same packing fraction in another terms. I can write it as packing fraction is equals to number of atoms by mass, okay ma, multiplied by volume of each atom divided by volume of unit cell. So like this also you can write. Are you able to understand ma? So each unit cell will have different number of atoms no ma? Are you able to understand? For example, a primitive unit cell, it will have only one atom by mass. Okay? Body centered, it will have 2 atoms. Face centered, it will have 4 atoms. Are you able to understand? So what is the equation I have written? Number of atoms by mass covered by the unit cell multiplied by volume of each atom. Then you will get total volume of atoms, no? Divided by what? Divided by total volume of the unit cell. Then you will get the percentage of atoms which the atoms are covering this unit cell. Enta fraction cover avutundo vachestadi. Okay ma? Now let us do the calculation for primitive unit cell. Okay? So primitive unit cell has how many atoms by mass ma? Only one atom, no? So number of atoms by mass is 1. And what is the volume of each atom? Atom ఏ షేప్లో ఉంటుంది? ఫస్ట్ స్ట్రైట్గా రాడ్ లాగా ఉంటుందా, కోన్ ఐస్ క్రీమ్ లాగా ఉంటుంది, ఎలా ఉంటుంది మరి? స్పెరికల్ షేప్ను. సో వాట్ ఈస్ ద వాల్యూమ్ ఆఫ్ ఎ స్పియర్? వాల్యూమ్ ఆఫ్ ఎ స్పియర్ 4/3 pi r cube. 4/3 pi r cube. So this is the volume of a sphere, no ma, where r is the radius of a sphere. Are you able to understand? So divided by, now can you say what is the volume of a unit cell? A cube. Volume of a unit cell is A cube. So just if you do this calculation, then you will get the packing fraction. Are you able to understand ma? Primitive unit cell covers one atom by mass. Oka atom e untundi kada final ga dantlo one atom. Volume of each atom divided by volume of unit cell. Are you able to understand? So therefore, see ma, here R I have and here A I have. Already we calculated relation between A and R, no? What is the relation? A is equal to 2R. Substitute here. So we know that A is equal to 2R, no? So therefore packing fraction of primitive cubic unit cell is how much ma? So 4 by 3 pi R cube divided by 2R whole cube. Okay? So if I do this calculation, what I will get? R cube get cancelled. 8 will be there. So 4 pi by 8 into 3. So therefore it is pi by 6. Pi by 6 only, na? 3.14 divided by 6, slightly greater than 1 by 2. So it is approximately 0.52. Okay, ma? So which is the packing fraction? How much is the packing fraction I got? 0.52. Are you able to understand? 0.52 means what? 52% of the unit cell is completely filled. Primitive unit cell lo enta space occupy ayi untundi? 52%. Then what is the void space? 48% is the void space. Understood, number? So write down. Therefore what I write? Therefore, okay ma? Therefore 52% of PCC is filled and 48% is void. Okay ma? That's it. That completes our discussion on PCC. Primitive unit cell gurinchina information adi. Are you able to understand ma? So therefore once let us revise primitive unit cell. How many atoms are there in primitive unit cell ma? 8 atoms are there. Where they are present? At the corners. Are they touching or not? Definitely they are touching with each other. Are you able to understand ma? So touching with each other ante anni touch ayyavayo aa edge length lo unnayi maatrame touch avutayi. Are you able to understand ma? So the face diagonal atoms, they do not touch. Body diagonal atoms also, they do not touch. Atoms which are only present on the edges, only they will touch. And by mass, how many atoms will be present? Only one atom will be present. And what is the packing fraction I got? Packing fraction is 0.52. And in percentage, if I want to write, it is 52% or 48% is empty. Void space means empty space. Are you able to understand? So the second type of unit cell which we are studying is BCC. What is meant by BCC? Body centered cubic cell. Okay? So listen very carefully. Sima, as usual, just like primitive cell, 8 atoms they are present at the corners. 8 corners are there, no? 8 atoms will be present. And in addition to them, there is one more atom exactly at the center. Madhyalo oka atom untundi. Are you able to understand ma? And which atoms are touching and which atoms are not touching, that is very important. Are you able to understand? See ma, these corner atoms, they are not touching with each other. Already I said, you know, corner atoms will be touching only in the case of primitive cell only. In other type of cells, corner atoms will not be touching. So these atoms, they are not touching. But this central atom, this will be in contact with all the 8 corner atoms. How many corner atoms are there? 8. So this middle atom, which is present exactly at the middle of this volume. So this atom, it will be contact with all the 8 corner atoms which are present. Are you able to understand? So if I need to draw a diagram, I can draw a diagram like this, ma, for example. So consider here there is one atom. Okay, ma? Consider this is one atom. And consider next which face? This is the outer face, no, ma? Which one is the outer face here? Let us call this is the outer face. Or I will draw one more diagram. See, ma. So let us take this is one face. Okay. So here there is one atom. Okay. Here there is one more atom. Here there is one more atom. And here there is one more atom. These are the corner atoms. Okay. And exactly at the middle of the volume. See, ma, this atom, it is not present on the face. ఈ ఆటం ఎక్కడ ఉంది? ఫేస్ పైన లేదు. క్యూబ్ ఏది? ఏమో ఎప్పుడే తీసేసుకున్నాను. ఓకేమా? సిమ దిస్ మిడిల్ ఆటమ్, ఇట్ ఈస్ నాట్ ప్రెసెంట్ ఆన్ ద ఫేస్. ఫేస్ పైన లేదు. ఇట్ ఈస్ ప్రెసెంట్ ఇన్సైడ్ ద వాట్ యు కాల్ దిస్ సెల్. సెల్ లోపల ఉంది అది. అర్థమవుతుంది కదా? So therefore, the atom which is present inside this cell, it is in contact with all the corner atoms. Okay. So on one face you will have 4 corners, no? 4 corner atoms. On the back side also you will have 4 corner atoms. So this middle atom, it is in contact with 8 corner atoms. Anni corner atoms lo adi touch lo untundi. So this is the point in which the atoms they are touching and the atoms which are not touching. Are you able to understand? That's it. Okay. So therefore, again we do again concept number 1. Okay, ma? Which is the concept number 1 here. Number of atoms by mass, okay, ma? Enclosed by body centered cubic cell. Okay, ma? So by mass, it is enclosing how many atoms? Okay, very easily you can say, no? 8 corner atoms will make 1 atom, no? 8 corner atoms will make 1 atom, and in the middle there is one more atom. So totally 2 atoms. That's all, very easily you can say. Okay, or if you want to do with the help of calculation, you can always do. Which calculation? Number of atoms at corners divided by 8. Number of atoms at edges divided by 4. Number of atoms at where face divided by 2. Number of atoms at center divided by 1. This is the formula, no? Okay, so apply this formula. How many atoms are there at the corners? 8. So 8 by 8. How many atoms are there at edges? No atoms are there at the edges. 0. How many atoms are there at the face? No atoms. This is also 0. How many atoms at the center? 1. 1 divided by 1? 1. So totally 1 plus 1 is how much? 2. That's what I said, no? Okay, ma? So BCC cell, it will enclose how many atoms, ma? It will enclose 2 atoms. So this is the formula which you should remember. Okay. So corners lo 8 ఉన్నాయి కదా, మధ్యలో ఒకటి ఉంది. Okay, so total 1 plus 1, 2 atoms will be enclosed by this body centered cubic cell. Okay. Next concept, concept number 2. Concept number 2, what is that? Again same concept, relation between, okay, ma? Relation between radius of atom and edge length. Are you able to understand, ma? So previously we have derived a relation between edge length and radius to be A is equal to 2R, no, ma? That concept I cannot use here. What is the reason? Edge atoms, they are not touching, no? Edge atoms, they are not touching. So I cannot say that 2R is equal to A, that I cannot say. Okay. Now to calculate relation between radius and edge length, which 2 atoms I have to take, or which group of atoms I have to take? A atoms తీసుకోవాలి. I have to take those atoms which are touching. Touching అవుతున్నవి తీసుకుంటే సరిపోతుంది కదా. Which atoms are touching, ma? 1 corner atom, middle atom, 1 more corner atom. Body diagonal. This is not face diagonal. ఇది face diagonal కాదు, ఇది body diagonal. Why? This atom, is it present on the face? Face పైన ఉందా ఇది? No, it is present in the inside the body. Are you able to understand? So this diagonal will become body diagonal. It is not a face diagonal. So this diagram is definitely a face only. But this middle atom, is it present on the face? Face pine unda adi? Sima, for example, here there is 1 atom, here there is 1 atom, and on the face also if you have 1 more atom, then these 3 atoms, they are in 1 line. Ante kada? But this atom, is it present on the face? Madhyalo undi kada? It means which length you have to take? So consider this one, 1, 2, 3, 4. Okay, ma? 5, 6, 7, 8. Okay. So which 2 atoms they are touching? So this is present inside the board. Point number 6 is present outside the board. So this atom and this atom, they are touching with each other. Let us call it as point 8. Are you able to understand? So 1, 8, 6, they are in a straight line. Similarly, you can say here 8, this is also 8, let us call it as 9. Okay, ma? 8, 9 and 3. 3 na? 2. 8, 9 and 2, they are in a straight line. I can say like this. Are you able to understand, ma, what is happening? Okay. So therefore what I say, so the atoms on body diagonal, atoms on body diagonal are in a straight line, and touching also. Touch kuda avutunnai kada, they are touching also. How can I say they are touching? Because already I said you that central atom, it is in contact with all the corner atoms, no? So definitely they are touching with each other. అర్థమవుతుందమ్మా? 3 dimensional ఆలోచించాలి. You have to use your brain in 3 dimensions. Are you able to understand? Okay. Now can you say what is the distance between this point and this point, ma? What is the distance between 1 and 6? Root 3? Yeah, root 3a. Very good. Okay, ma? So distance between 1 and 6 points, it is equals to root 3 into a. Okay? And this root 3 into a is equal to how much in terms of radius? Radius prakaram తీసుకుంటే. So from here to here r, no? Radius. Here to here 2r. Again here to here r. Totally how many? 4r. అంతే కదా? So this corner atom, it is in contact with middle atom. So that distance is r. Total diameter of middle atom is 2r. And corner atom radius is again r. So distance between one edge to another edge. Okay ma? One corner to body diagonal, another corner. That is how much? That is exactly equal to 4r. So that is equal to 4r. Are you able to understand ma? So therefore what is a value I got? A value is equals to 4r divided by root 3. So this is the relation between what? Body, what you call atomic radius and edge length. Okay ma? A means edge length only, no? R means radius. This is the relation. In PCC what I got? A is equal to 2r. But here A is equals to 4r divided by root 3. That is how we calculate the relations. అర్థం అవుతున్నాయి కదా? Okay. Clear ma? Similarly, next I calculate, okay, in the same concept, first one. So distance between nearest atoms. Can you say? What is the distance between nearest atoms, ma? Distance between nearest atoms. Which are the nearest atoms? The atoms which are touching. The atoms which are touching, they are the nearest atoms, no? So definitely I can say that one corner atom and one middle atom, they are touching with each other, no ma? Are you able to understand? So one corner atom and one middle atom, they are touching with each other. So distance of center of the center atom and distance of center of corner atom, this distance is the shortest distance. Clear, no? Are you able to understand ma? Now how much will be the distance? 2r. 2r is fine in terms of edge length. 2r అందరికీ తెలుసా? ఇది ఎడ్జ్ లెంత్ ప్రకారం ఎంత ఉంటుందో చెప్పండి. ఇన్ టర్మ్స్ ఆఫ్ ఎడ్జ్ లెంత్ హౌ మచ్ ఇట్ విల్ బి? టోటల్ లెంత్ ఇస్ root 3a, no? Then this is half of that. Half means root 3a by 2. That is the shortest distance. Okay ma? So this is how much ma? Root 3a divided by 2. Because length of body diagonal root 3a. This is only half of that, no? So root 3 into a. This is the shortest distance between two atoms. Are you able to understand? In PCC, these two are touching. So shortest distance was a. But now here these two, they are not touching, no? But middle one and corner atom, they are touching. So that distance is half of the body diagonal. అర్థమవుతుంది కదా? So that is root 3a by 2. Okay. So next shortest distance. Next shortest distance is how much? Next shortest distance between two atoms is nothing but the distance between the atoms which are present on the edge. Edge. Edge is a only, no ma? This is shortest distance. Next shortest distance is this one. కొంచెం ఎక్కువ ఉండాలి. దీనికన్నా కొంచెం ఎక్కువ ఉన్నది ఇదే కదా? A. Values ప్రకారం కావాలంటే చూడండి. root 3 value is how much? root 3 value is 1.732 divided by 2 into a. Less than 1, no? Less than a. So next shortest distance is slightly greater distance, and that is definitely a only. Are you able to understand? So therefore next shortest distance is what? A. Next to next shortest distance? ఆలోచించండి. Next to next Shortest distance. Root 2? 2a only. Again, why 2a by 2? Clear, Nama? Sima, if this is the next shortest distance, then we have phase diagonal. No? Sima, fourth point, it is present outside the board. Sixth point also present outside the board, no? Fourth point is present outside the board. Sixth point kuda ekkadundi outside the board. So this is the next shortest distance. This distance already I have taken, no? So this will be the next one. Distance between 4 and 6. Okay? So this is what distance between 4 and 6. And how much it will be? Root 2a. That is phase diagonal, no? Length of phase diagonal is how much? Root 2 into a. This is phase diagonal. Okay? So this is how you can calculate the values. Are you able to understand? Kavalante values calculate cheyandi. 1.732 by 2 is less than a. A is less than root 2 into a. Is it clear? So these are the distances in the case of which cell? In the case of body-centered cubic cell. Is it clear? Okay. So concept number 2 is completed. Next we go to third concept, coordination number. Okay, ma? Coordination number. Okay, ma? And coordination number already I said you know to by heart this one. What is the coordination number of BCC? Coordination number is 8. This you have to by heart. Are you able to understand, ma? Fourth concept. Concept number 4, packing fraction. Okay, and what is the equation of packing fraction? Already I have written in the previous concept too. So directly I am writing here. So number of atoms by mass multiplied by volume of each atom divided by volume of unit cell. Volume of unit cell. Clear? Now let us do the calculation. Okay, so this value you should remember. Remember the relation between A and R. Okay, so A is equals to 4R by root 3. And BCC is enclosing how many atoms? 2 atoms. PCC, 1 atom. BCC, 2 atoms. FCC, 4 atoms. FCC will enclose 4 atoms. Are you able to understand? Now see. So therefore packing fraction is equals to how many atoms are enclosed, ma? 2 atoms are enclosed by BCC multiplied by volume of each atom 4 by 3 pi r cube, and volume of primitive cell is a cube. That's all, no? Substitute. So write instead of a I can write 4r by 3 pi, no? Substitute there. So 2 into 4 by 3 pi r cube divided by a value is 4r divided by root 3 whole cube. Are you able to understand? Now see which are the terms which can get cancelled, ma? So 2 into 4 by 3 multiplied by pi r cube divided by 4 cube multiplied by r cube multiplied by 3 root 3. That's all, no? So r cube and r cube get cancelled. So here I will get to square. Here I will write down, ma? So therefore do this calculation, ma? You do this calculation when you are free. Directly I am writing the answer, ma. The answer which you will get is 0.68. This is the answer which you should get. Okay, ma? 0.68. And what is meant by 0.68? 68% of the cell is completely filled, and 100 minus 68, 32% is void. That is the meaning of this one. Are you able to understand, ma? Therefore 68% is filled and 32% is empty. Empty in the sense it is void. Okay. So these are the 4 concepts which we study in the case of body-centered cubic cell. Clear? That's it. So next one which we are studying is face-centered cubic cell. Okay. What is meant by face-centered cubic cell? See, this unit cell, this cube has how many corners? 8 corners are there. So each atom is present at 8 corners. So here one, here one, here one, here one. So totally 8 atoms are filled. Okay. And how many faces are there? 6 faces are there. So at the center of each face there is one atom. Are you able to understand, ma? So totally 6 faces, 6 atoms, 8 corners, 8 atoms. 8 plus 4, 14 atoms are total. 8 plus 6. What did I say? 8 plus 6 totally 14 atoms will be present. Are you able to understand? Now the question is, which atoms will touch with each other and which atoms doesn't touch with each other? Now first of all let us see. See ma. So these thick atoms, they are the atoms which are present at the corners. And here we have just dotted atoms. They are the atoms which are present at the faces. So this one is present on the top face. This one is present on the side face. This is also present on the next side face. This one is present on the bottom face. This one is present on the face which is out of the board. This one is present on the face which is present inside the board. So totally 6 faces, 6 atoms. Are you able to understand? Now see ma. So here see the note point. Corner atoms, they never touch. Already I said, corner atoms will be touching only in the case of PCC. Remaining atoms, they never touch with each other. Okay. Next is opposite phase atoms never touch. Okay. See, listen very carefully. So this atom and this atom, they never touch with each other. Okay. This atom is present on one face. This atom is present on the opposite face. So these two atoms, they doesn't touch with each other. Similarly, this atom and this atom, they are again on the opposite faces. They never touch on each other. Similarly, if I call this as first atom and second atom, 1 and 2 also, they never touch with each other. So చూడడానికి దగ్గరగా ఉన్నాయి, టచ్ అయ్యాను అనుకుంటారు. So 1 is present on outside of the face. So 2 is present on the inside face. So they never touch with each other. Okay ma? Then which are the atoms which touch with each other? Okay. For example, if you take this atom, the one face atom, this is in contact with all the 4 corner atoms which are present on the same face. Okay ma? So 3, 4, 5, 6, 7. Okay. 7 is in contact with 3 also, 4 also, 6 also, 5 also. Are you able to understand ma? So if you want to make a note, so draw those numbers ma, we will write so that you can understand better. 1 and 2 never touch. They are not touching with each other. Are you able to understand ma? Then 7 is in contact with what? It is contact with 3, 4, 5 and 6. Okay ma? It means the face atom, it is in contact with corner atoms of the same face. వేరే ఫేస్ తీసుకోకూడదు, మళ్ళీ మీరు అదే ఫేస్కి సంబంధించిన కార్నర్ ఆటమ్స్ని టచ్ అవుతూ ఉంటుంది. సిమిలర్లీ this phase atom, it will be in contact with adjacent phase atoms. Adjacent phase అంటే మని పక్కన ఇంకో ఫేజ్ ఉంటుంది కదా, వాటితో మళ్ళీ కాంటాక్ట్లో ఉంటాయి. There is one phase which is called opposite phase. Okay ma? Sima. So this is one phase. Which is the opposite phase? This is the opposite phase. So this atom and this atom, they never touch with each other. Okay. But one phase atom, it is in contact with adjacent phase atoms. How many adjacent sides are there to this one? 4 adjacent sides are there. To this phase, this is adjacent phase. No? This is also adjacent phase. This is also adjacent phase. This is also adjacent phase. So the atom which is present at one phase, it will be in contact with 1, 2, 3, 4 phase atoms. But the 5th phase atom is in the opposite side. No? With that one, it will not be in contact. It means 5 phase atoms always they are in contact. 1 phase atom is not in contact. That is the point which you should understand. So this is slightly complicated when compared to previous ones. అర్థమవుతుంది కదా? Corner atoms never touch. Are you able to understand ma? Opposite phase atoms, they never touch. But the atoms which are present on the same phase, they are in contact with all the corners. Okay ma? And they are also contact with adjacent phases. One phase, it will not be in contact. Which one phase atom? That is the phase which is present on the opposite side. Are you able to understand? That's it. So that is the case in which these atoms, they are touching and the atoms which are not touching. Clear? Come on. Now after this we have completed, then what is the first concept ma? Concept number 1. 4 concepts we were discussing, no? Concept number 1. What is concept number 1? Number of atoms by mass enclosed by FCC. Are you able to understand, ma? And which is the formula? So number of atoms enclosed formula is number of corner atoms divided by 8, number of edge atoms divided by 4, number of face atoms divided by 2, and number of center atoms divided by 1. Okay, now you can do the calculation, no? So how many corner atoms? 8. 8 by 8, 1. Edge, 0. 0 by 4. Face, 6. 6 by 2. Center, 0. 0 by 1. So 1 plus 3 is how much, ma? 4. That is my answer. So this FCC, it is equivalent to enclosing 4 atoms. So దాని లోపల మాస్ ప్రకారం తీసుకుంటే 4 ఆటంలు ఉన్నట్లు లెక్క. ఓకే, PCC 1 atom, BCC 2 atoms, FCC 4 atoms. Understood, Doma? That's it. Remember up to here, then we will continue this in the next class. So the second concept is relation between radius of atom and edge length. Okay, ma? Now see here, see ma, in this type of questions you have to take those 2 atoms which are touching with each other. Already cheppinanu kada. To calculate relation between radius and edge length, what you have to take? You have to take those 2 atoms which are touching with each other. Touch lo ఏవవుతున్నా అవి తీసుకోండి, ఇంకా ఈజీగా వస్తుంది కదా మీకు. Which atoms are touching here? See ma. So this is one face atom, no, face center atom, and this is the atom at the corner. These 2 definitely they are touching, no? Already we discussed, no, ma? So draw the diagram here. So therefore if I draw one face, how will be that face? Oka face draw chesta unnanu. So here there is one atom which is exactly at the center of the face. Are you able to understand, ma? And let us try a bigger one. So here there is one atom at the center of the face, and here there is one more atom which is exactly at the corner. So these 2 atoms, they are touching with each other. Are you able to understand, ma? And now can you say what is this distance? This distance will be how much? R. So this is 1 R, this is another R. So total 2 R. So distance between 2 atoms is 2 R. Are you able to understand? Now can you say if this is one face, this becomes body diagonal or face diagonal? అది ఒక ఫేస్ అనుకుంటే అది ఫేస్ డయాగ్నల్ అవుతుందా, బాడీ డయాగ్నల్ అవుతుందా? ఫేస్ డయాగ్నల్. వాట్ ఈస్ ద లెంత్ ఆఫ్ ఫేస్ డయాగ్నల్? Face diagonal in terms of edge length, it is √2 into a. So this is a and this is a, no ma? Apply Pythagoras theorem. Square root of a square plus a square, √2 to a. So bara vinali first. Are you able to understand, ma? So therefore this total face diagonal is how much? √2 into a. And this is also half of the face diagonal, no? This length is how much? Half of the face diagonal. So therefore can I say that 2r is equals to √2a divided by 2. Can I say like this? Ante kada? So therefore what is a value? So therefore √2a is equals to 4r. So a is equals to 4r divided by √2. 4 can be written as 2 into 2 into r divided by √2, no ma? So therefore finally how much it is? 2 √2 into r. That is the relation between edge length and radius. అర్థం అవుతుందా ఎలా చేస్తున్నాము? Are you able to understand, ma? So this is the distance between 2 atoms. So in between 2 atoms, distance means from where you have to take, ma? Distance ante ekkadi nunchi teesukovali? From the center of the atom. Clear, no? So one radius is r, another radius is r, total 2r. And these 2 atoms, where they are present? They are present on the face only. This is also at one corner, this is exactly at the center of the face. They are in a straight line, no? And that straight line is present where? That straight line is present on the face. And face diagonal length is √2 into a. So this distance is exactly half of that. Are you able to understand? So therefore this is the relation between what? Radius of the atom and edge length. Understood, Nama? Okay. So next calculation I will write here. Now can you say what is the distance between nearest atoms? Distance between nearest atoms is how much, ma? Huh? In terms of edge length. Distance between 2 atoms is definitely 2r only because any 2 atoms are always touching, no? This is the distance 2r, and 2r is equals to how much? That's it. Are you able to understand, ma? So distance between nearest atoms is nothing but 2r in terms of radius, and that 2r is nothing but root 2a by 2. So how much? A by root 2. A by root 2 only, no? A by root 2. నువ్వు ఇంతమంది ఇదేనా చెప్పింది? Then it is correct. Are you able to understand? But I was asking relation, no? So you should have said that 2r is equal to a by root 2, then it is correct. Are you able to understand? Okay. So then next to next nearest distance, ma? Next to next nearest distance is how much? First of all, we write next nearest distance. This one. Same one. This is the diagram. Clear, ma? Next one nearest distance I have calculated a by root 2. Next nearest distance. See, ma, first nearest distance is nothing but the atoms which are touching. Clear, no? Next nearest distance, shall I take this atom and this atom, or this atom or this atom, or directly body diagonal I shall take? Which one shall I take? Okay. Now I have taken distance between this one and this one, no? Because these two atoms, they are touching with each other. That is the shortest distance. Next shortest distance will be how much? It will be A. That is the distance between two atoms which are present at one corner of two corners of one edge. అర్థమవుతుంది కదమ్మా? So this is the next nearest distance. Okay. So distance between this atom and distance between this atom. Next nearest distance. First nearest distance 2r, which is equal to a by root 2. Second nearest distance is a. Okay, ma? Next one is next to next nearest distance. Next to next nearest distance is which one? Can you say? ఆ తర్వాత నెక్స్ట్ డిస్టెన్స్ ఏది ఉంటుంది? ఎక్సెల్ పంపిస్తే అమౌంట్ వేస్తా. ఇట్లా మోసపోయిన వాళ్ళు కూడా ఉన్నారు తెలుసా మీకు? ఓకే, చెప్పండి. సో ఫస్ట్ నియరెస్ట్ డిస్టెన్స్ ఏ బై రూట్ 2. నెక్స్ట్ నియరెస్ట్ డిస్టెన్స్ ఏ. నెక్స్ట్ టు నెక్స్ట్ నియరెస్ట్ డిస్టెన్స్ సిమా. ఫస్ట్ ఆఫ్ ఆల్ దిస్ ఈస్ ద షార్టెస్ట్ డిస్టెన్స్, ను నెక్స్ట్ దిస్ వన్. నెక్స్ట్ ఏమై ఉంటుంది? నెక్స్ట్ డిస్టెన్స్ విల్ బి డెఫినెట్లీ ఫేస్ డయాగ్నల్. ఓకే, అండ్ ఫేస్ డయాగ్నల్ ఈస్ హౌ మచ్? ఇట్ ఈస్ 2a. ఫేస్ డయాగ్నల్ ఈస్ root 2 into a, no? root 2 into a. Okay, first nearest distance, second nearest distance, third nearest distance. If you want to fourth nearest distance, that becomes the body diagonal. So like this you can go on calculating the distances one by one. Are you able to understand? If you want to do the calculations you can do, then also you can see that this sequence is correct. Okay? Okay, ma? So then we study about coordination number. What is meant by coordination number, ma? Concept number 3. Coordination number. What is meant by coordination number? The number of atoms surrounded to a single atom which are present at the shortest distance. Already we have discussed, Nama. You need not understand them, you just by heart them. So for FCC, the coordination number is how much? 12. It means each atom is surrounded by how many atoms which are present at the shortest distance? 12 atoms. So its coordination number is 12. Clear? Okay. So next, concept number 4. Packing fraction. Okay. What is the formula of packing fraction, ma? So, number of atoms by mass multiplied by volume of each atom divided by what, ma? Divided by volume of unit cell. Okay, that's all. Okay. So how many atoms are enclosed by FCC, ma? Chapandi. FCC encloses how many atoms by mass? 4. Already calculate చేసినాం కదా, ఏ లోకంలో ఉన్నారా మీరు? 4 atoms. And volume of each atom? 4 by 3 pi r cube. Volume of unit cell? Volume of unit cell is just a cube. That's all, no? Now already we have calculated a relation between a and r, no? What is that relation? A is equals to 2 root 2 into r. So substitute that one. Okay, ma? ఆల్రెడీ రిలేషన్ ఫైండ్ అవుట్ చేశాం కదా, జస్ట్ యూ నీడ్ టు సబ్స్టిట్యూట్ ఇట్. సో దేర్ ఫోర్ 4 into 4/3 pi r cube multiplied by, instead of here I have to write 2√2 r whole cube. Okay, now I will not do this calculation, you do this calculation. The answer which you will get is 74 or 0.74. That is what you will get. Okay ma? So how much is the packing fraction? 0.74. It means that 74% of unit cell is occupied. If 74% is occupied, then how much percentage void? 24 hours. 26% is void. Void means what? Empty. Okay ma? So that is our discussion on these unit cells. Primitive cell, base, body centered cubic cell and face centered cubic cell. Are you able to understand ma? So previously, at least for every alternate year, you were getting one question on this one ma. Okay, so be careful about this, all the 4 concepts which we have discussed. Okay, let's fill this table ma. So 3 types of unit cells we have taken: primitive cubic cell, body centered cubic cell, face centered cubic cell. So how many atoms by mass they are present at the corners, that I want to calculate. Clear na ma? So totally 8 corners are there no, and at each corner we have 1 atom, and how much is the contribution of each of it? 1/8. So therefore 1 atom will be enclosed when atoms they are present at the corners. Okay ma? Same is the case with the BCC also, same is the case with FCC also, because in all of them atoms they are present at corners no. So 1 and 1. Okay ma? Next at center 0. Clear na ma? FCC also 0. BCC is 1, and 1 into 1 it is 1. Are you able to understand? This is what we have calculated no. At the base, at the body, inside the body, only in BCC only we have 1 atom, and it is present exactly at the center no ma. That atom is not shared by other unit cells. వేరే యూనిట్ సెల్స్ దాన్ని షేర్ చేసుకోలేదు కదా, సో టోటల్ ఆటమ్ ఈస్ ప్రెసెంట్ ఇన్సైడ్ దట్ యూనిట్ సెల్ ఓన్. సో 1 atom is present, and how much will be contribution? 1. So 1 into 1 is 1. Okay, so next at face, so here it is 0, BCC also it is 0, but here FCC total 6 atoms are present. And when atom is present on the face, how much will be the contribution of each atom? 1/2. ఆల్రెడీ చదువుకున్నాం కదా, ఫేస్ పైన ఉందనుకోండి, ఆ ఫేస్ పైన ఇంకొక యూనిట్ సెల్ పెడితే 2 యూనిట్ సెల్స్ ఒక పూర్తి ఆటమ్ని కవర్ చేస్తాయి. సో దేర్ ఫోర్ 6 into 1/2 is how much ma? It is equal to 3. So total number of atoms by mass is how much? Total number of atoms by mass. So here it is 1, BCC it is 1 plus 1 it is 2, it is 3 plus 1 it is equal to 4. Okay ma? So this diagram you should by heart this one. ఇది మీకు గుర్తుండాలి. అర్థమవుతుంది కదా? That's it. So primitive cell or simple cell, it will enclose only 1 atom. Okay ma? Body centered cubic cell, it will cover 2 atoms by mass, and face centered cubic cell it will cover 4 atoms by mass. Understood no? And you have to remember the relation between edge length and what you call radius of the atom also. అది కూడా మీరు గుర్తుపెట్టుకోవాలి. Are you able to understand ma? For PCC, primitive cubic cell, what is the relation between edge length and radius ma? A is equal to 2r. This is the relation no? Okay. For body centered cubic, see what is the relation? So A is equals to 4r by root 3. A is equals to 4r divided by root 3. This is the relation. For FCC, so A is equals to 2√2 into r. So these relations also you have to remember. Understood no? Clear ma? These are the relations. Next we will see about packing fractions also. Okay, so packing fraction for BCC is how much? PCC packing fraction is 0.52, or you can say 52% is full and 48% is void. Understood no ma? For BCC it is 0.68. It means 68% is filled and 32% is void. Understood, Amma? And for FCC, 7.74. 74% is completely filled, 26% is void. Okay, ma? These relations you should remember. Is it clear? That's it. So, how to calculate the formula of the compound mile? By looking at which atoms are present at which position. Are you able to understand? Atoms can be present at corners, no? Remember first. Atoms can be present at body center also. Atoms can be present at edges also. Atoms can be present at face also. Are you able to understand? So based on that, how to calculate the molecular formula of the compound. So depending on the structure and arrangement of atoms only, formula will be dependent to number. So a molecule formula denipaina depend avutundi. It depends on structure of that. I mean, you should have studied in chemical bonding, no? Are you able to understand? Now see, ma'am. So the number of atoms by mass ratio of different atoms, it gives the molecular formula of the compound of different atoms. Are you able to understand, ma? So which ratio I am supposed to take? A ratio తీసుకోవాలి నేను. I have to take that ratio, which is the ratio of the number of atoms by mass of different atoms. That's all. Okay. For example, let us see one example here. We will try to understand by taking this example. So a compound is formed by elements X and Y. It means X is one element, Y is another element. That is the meaning of this one, no? So it crystallizes in a cubic crystal in which X atoms they are present at corners and Y atoms they are present at the face centers. So then what is the formula of the compound? See, ma, X atoms doesn't mean number of atoms, no. X atoms means these are the atoms of X element. Y atoms means what? These are the atoms of Y element. Okay. So in this crystal, where atoms are present? Atoms they are present at corners and atoms they are present at face centers. Which type of atoms are at corners? The atoms belonging to X element, they are present at the corners. And the atoms belonging to Y element, they are at the face centers. Then what will be the formula of this crystal? This crystal formula, molecular formula, ela untundi. Clear, nama? What we have written here? The number of atoms by mass of different atoms. Just that one will give the formula of the compound. Are you able to understand? Now see. So therefore, at corners, which atoms are present, ma? X type of atoms are present. That's all, no? X type of atoms are present. So how many corners will be there, ma? 8 corners will be there. And what will be the contribution by each atom? 1 by 8. Wow, each atom will contribute to 1 by 8 when atoms they are present at the corners. Already chadukunnam kada. So 8 into 1 by 8 is how much? 1. Are you able to understand? Now let us write at faces. Okay, ma? So on the center of the face, which atoms are present? Face center lo evunnai? Y type of atoms are present. Y type of atoms are present. Okay. So at the corners, X type of atoms are present. At the faces, Y type of atoms are present. Are you able to understand, ma? And how many faces are there, ma? 6 faces will be present in a cube. And each atom at each face, it contributes how much by mass? 1 by 2. So 6 into how much? 1 by 2. 6 into 1 by 2 how much? 3. Are you able to understand? So 1 atom of X is enclosed and 3 atoms of Y is enclosed. Are you able to understand? Therefore, molecular formula of crystal is nothing but, okay, ma? XY3. This is the relation. That's all. Are you able to understand, ma? Molecular formula can be derived by just the ratio of different types of atoms by mass present at different locations. That's it. Okay. So X atoms, how many X atoms are present? 1 in that unit cell. And how many Y atoms are present? 3. So that is what is the molecular formula? XY3. That's all. Understood, no? Here, so this is one more question to find out the molecular formula of a compound. So listen carefully. So A type of atoms, they are present at coordinates. Okay. B type of atoms, they are present at one alternate phase. What is meant by one alternate phase? How many phases are there, ma? 6 phases are there totally. In a cubic crystal, you have 6 phases. How many alternate phases are there? 3 alternate phases. Opposite phases మూడే కదా ఉండేది. సో ఇటు ఒక ఆపోజిట్ ఫేస్ 2, ఇటు 2, ఇటు 2. 3 alternate phases. It means totally 6 phases. Are you able to understand? It means on only 2 opposite phases, each atom is present. On remaining 2 alternate phases, atoms are not present. That is the meaning of this one. And C type of atom exactly at the center. Are you able to understand? Now let us see. So therefore, at corners, which atoms are present? A type of atoms are present. Okay. So therefore, at corners totally 8 will be there, and its contribution is 1 by 8. So 8 into 1 by 8 is 1 atom by mass. 1 atom by mass is enclosed by the unit cell when atoms are present at the corners. Clear now? Next, at alternate phase. Alternate phase, which type of atoms are present? B type of atoms are present. Okay, ma? So alternate phase means only 2 atoms. No? Are you able to understand, ma? So for example, see ma, here I am drawing the diagram. Okay. So this is one alternate, this is one phase. Here there is one atom exactly at the center. This is the exactly opposite phase. So only on one alternate phase. Not alternate, alternate phase. Are you able to understand, ma? So therefore, how many atoms totally? 2 atoms. And what is the contribution of phase atoms? 1 by 2. So 2 into 1 by 2? 1. Understood, no? Now at the center? Center, how many atoms are there? At center only 1 atom can be present. Clear, ma? Which type of atoms? C type of atoms. Are you able to understand? So 1 atom is present and its contribution is completely 1, so 1. So at the coordinates, contribution is 1. Phase contribution 1. Center contribution 1. So therefore, what is the molecular formula? Molecular formula is ABC. That is my answer. Understood, no ma? Ala calculations cheyali. Okay? Okay, ma? So see this next question, ma. A given metal crystallizes as a cubic structure having edge length. So what is meant by edge length, ma? Edge length is nothing but A, no? A value is 361 picometer. So there are 4 metal atoms in unit cell. What do you understand by this one? PCC, na? No. Okay, ma? So if there are 4 metal atoms in unit cell, means one unit cell is enclosing 4 atoms by mass. And which unit cell encloses 4 atoms by mass? FCC. So this is an example of, so unit cell is enclosing 4 atoms by mass. That is the meaning of the statement which is given, ma. Therefore, what is the type of unit cell? Type of unit cell is FCC, face centered cubic cell. Understood, Nama? So in PCC, 1 atom will be enclosed. In BCC, 2 atoms will be enclosed. And in FCC, 4 atoms will be enclosed. That is the meaning of the statement, no? There are 4 metal atoms in unit cell. It means inside unit cell, 4 atoms are present. Are you able to understand? It means 8 atoms, they are present at the coordinates. 6 atoms, they are present exactly at the center of each phase. That is the meaning of this one. Okay. Now what is the radius of the atom? He is asking. So therefore in FCC, what is the relation between radius and bond length? 2r is equals to, directly relation we have derived, no? A is equals to 2 root 2 into r. This is the relation. Understood, no? Just substitute here. So therefore what is r value? R value is equals to A divided by 2 root 2. So A value is 361 divided by 2 into root 2 value is 1.414. Okay, ma? So do this calculation, whatever answer you will get, that is our answer. Okay, ma? So therefore, less than 150. Less than 150 means 127. That is my answer. So 127 picometer. That is how we have to calculate. Understood, Nama? Table. Remembering the table which we have written, that is very important. Once you remember the table, very easily you can calculate. But you should be very careful about the language which is asked in the question. The question he is asking. So A means edge length. A is represented by edge length only. We have also studied like that only. Then the ratio of atoms in terms of edge length. In simple, body centered and face centered. Already we have written a table, Nama. In PCC, primitive cubic cell. So A is equal to 2R. This is the ratio. So therefore R is equals to, or R1 is equals to A by 2. Okay. In BCC, what is the relation? A is equals to 4R divided by root 3. So therefore what is R value? Root 3A divided by 4. Let it be R2. In PCC, what is the relation? Sorry, FCC. FCC. So therefore A is equals to 2 root 2 into R. So therefore R is equals to A by 2 root 2. Okay, this is R3. So just he is asking the ratio of R1 is to R2 is to R3. Radius of ratio of radius only he is asking, no? So therefore do the calculation. Therefore R1 is to R2 is to R3. So how much more? So it is A by 2 is to root 3 A by 4 is to A by 2 root 2. Okay. So therefore A get cancelled, 2 also get cancelled. Okay, ma? So therefore 1 is to root 3 by 2 is to A by 1 by root 2. Okay, ma? If you want to further simplify, you can simplify by taking root 2 also, but up to here it is enough. This is the ratio. Understood, Nama? That's it. In the last class we have studied about basic unit cells, Nama. So primitive unit cell, and we have studied its 4 properties. Then we have studied about BCC, body centered cubic cell, and as well as we have studied about FCC. This we have studied, Nama. Now we are studying about how to pack a crystal. Are you able to understand, ma? So packing can be of many types. No? First of all, we will study about one-dimensional packing. What is meant by packing, ma? Arrangement of cells is nothing but packing. Are you able to understand? So first of all, if I study about one-dimensional packing, what is meant by one-dimensional packing, ma? Packing along any one dimension. Okay. So that is either lengthwise or breadthwise or depthwise. Okay, no? So along only one dimension, if I pack the atoms, then it is called as one-dimensional packing. And here 2 methods are possible. Clear, Nama? So let us see method number 1 and let us see method number 2. Okay. So what is meant by method number 1? I can pack the atoms like this, no? Okay, ma? I can pack the atoms with a small separation between them. Okay. So atoms can be packed with small separation. And one more type of packing is that I can pack these atoms without any separation also, no, ma? So I can pack them like this also. Okay. So out of first method and second method, which is a desirable method, can you say? A method baguntundantaru. Second method is more desirable. Are you able to understand, ma? So therefore we write, so method 2 of packing without gaps, okay, ma, is more desirable. Why? Because, what is the reason, ma? Because we need to have maximum packing efficiency. Okay, ma? Always what is desirable, ma? Always maximum packing is desirable. Are you able to understand? So therefore, instead of packing like this, if this is the packed structure, then this one is more desirable, because in some space, in same amount of space, more atoms can be packed, no? So this is the more desirable quantity. Are you able to understand? So instead of this one is a more desirable quantity. So this is about one-dimensional packing. Okay. Next I study about 2D packing. Okay, ma. Now what is meant by two-dimensional packing, ma? Packing in 2 dimensions. Lengthwise also as well as breadthwise also. In length and breadth I should have atoms. Depthwise we are not discussing. If I go to depthwise also it becomes a 3-dimensional packing. We are studying only about 2-dimensional packing. Clear, na, ma? First of all, let us take this array here. Okay, ma. So this is the array. Are you able to understand? So how I can pack these atoms? I can pack these atoms such that one atom is exactly below the other atom. So I can pack like this, no, ma? So this is one method of packing. Are you able to understand what is happening? One method of packing. Okay. So one atom is placed exactly below another atom. So like this you can place any number of groups or any number of columns. Are you able to understand? Now here one thing which you can observe is that, Klima, in this, in between these atoms there are some empty spaces also, no? Are you able to understand? So let us see by one more color here. So which is the empty space present here? Okay. So this is the amount of empty space which is present, no? These empty spaces are present. So this is also one empty space. Are you able to understand? Clear? So these empty spaces, what we call them, ma? We call them as voids. Okay, ma? And can you say what is the shape of this void here? Shape of the void you can call it as cubical. Cubical void. Okay, ma? Or just if you want to say in only 2 dimensions, you can say it is a square. Square type of void. Okay, ma? So this is the type of void which is existing here. This is one type of packing. Are you able to understand what is happening? Clear, no, ma? Similarly, similar method how I can pack. So this is the first method of packing. Okay, ma? First method. Now for example, if I take any one atom, okay, ma? Let us take this atom. Okay, let us take this atom to be my reference. This is my reference atom. Okay. Now this reference atom, it is being surrounded by how many atoms? The atoms which are touching with each other. So how many atoms are touching this particular atom? Can you say? 4 atoms are touching. No? What are the 4 atoms? So first one, second one, third one and fourth one. 4 atoms they are touching with each other. Are you able to understand? So therefore if I draw a figure here, clear, no, ma? So what is the figure formed, ma?
Square.
Square. So that is why this type of packing we can call it as square closed packing. This type of packing square closed packing we call it, because the unit cell which is formed here, it is in the form of a square. Are you able to understand, ma? So that is why what we call this one, this is called what? A square close packing. SCP. Square closed packing. Rhombus. Did I say rhombus? Rhombus also you can call it, but rhombus means angles may not be exactly 90 degrees. Are you able to understand? And distances also may not be exactly same. But here all the atoms they are having same radius and angles is also exactly 90 degrees. No? So definitely you should call it as a square closed packing. So this is one method of packing. Are you able to understand? So in this condition, the packing efficiency will be approximately 78.5. In which type of packing? In square close packing. Packing efficiency will be how much? 0.785. Or you can say in terms of percentage, you can say it is 78.5. Are you able to understand? So right. So this topic we have to deal very slowly, ma, otherwise you can never understand what is happening here. Okay? So, so in square close packing, okay, ma, okay, so see, ma, the packing efficiency of square close packing is how much? 52.4. And I will try to calculate its calculations, ma. Okay. So this is one type of packing, ma. So what is happening here? Below one cell I am placing one cell, and in between 4 cells you are finding a void. And what is the shape of the void, ma? You can call it as cubical void, or you can call it as a square type of void. Clear, no? So now let us see the second method of packing. Second method of packing the atoms in 2D space. Okay. So first of all, let us take one atom in one dimension. Okay. Now see, my second type of packing is that I can place atoms here also, no? I can place like this also, no? Are you able to understand, no? So this is the second type of packing. I can place atoms here also. So, okay, approximately like this. So very carefully we have to draw the diagrams, no? Otherwise horrible figures you will get. Okay. I think intakana ghoranga chestunaru meeru. I am better, I think. Are you able to understand? No? So this is the second type of packing which I can pack the atoms in two-dimensional space. Okay, ma? So now see here, atoms they are present only lengthwise and atoms they are present only in breadthwise. Only two types of arrangements. Either I can place atoms like this or I can place atoms like this. Are you able to understand? Now let us see the arrangement of voids in this condition. So where voids are present here. So this is one void, no? Okay, ma? And this is another void. This is another one. So this is another one. This is another void. This is another void. Okay. Now can you say what is the arrangement of these voids? So voids ela arrange ayi unnai cheppandi. Okay. So voids if I draw here. Voids if I draw here. So voids will be somewhat like this. Okay. This is ఇప్పుడు ఈ డయాగ్రామ్లు నేను చూస్తే అంతేనే మైక్. Okay. So this is the second type of arrangement number, and these are the voids. So one void is above the reference and one void is below the reference. Now can you say what is the shape of these voids? No? Triangular shape. So shape of voids is okay, ma? So triangular shape. This is the shape of the voids. Okay. And what is its packing efficiency or packing fraction? How much it is? 60.4%. This is the packing efficiency of this two-dimensional arrangement of these atoms, where atoms are arranged lengthwise as well as breadthwise. Are you able to understand? Okay. So make a note up to here. See, one more point here. For example, if I take this atom to be the reference atom. Okay, ma? Red color is there. Okay, ma? So if I take this atom to be my atom of reference atom, then can you say how many atoms are surrounded by this atom? 6, no? So how many? So this is one atom, so this is second atom, so this is third one, this is fourth one, this is fifth one, and this is the sixth one. Are you able to understand? So totally 6 atoms are being arranged here. Are you able to understand? Now if I draw the figure here, let us see how I can draw the figure, ma. So this is the line which is joining these two centers. Clear, no, ma? And this is the line which is joining the centers of these two atoms. Now these two they are joined like this, and these two they are joined like this. Okay, ma? These two atoms are arranged like this, and these two atoms they are arranged like this. Okay. So what is the type of unit cell which is formed here, ma? Hexagonal shape. Okay. So in this type of arrangement, the type of shape was square. But here the type of shape is what? Hexagonal. So therefore this is called as what kind of arrangement? So this type of packing is called, okay, ma? So hexagonal closed packing. Are you able to understand? Where each atom is surrounded by 6 other similar atoms. Understood, no? So therefore in 2D packing, totally how many types of packing we have? One is a square closed packing, another one is hexagonal closed packing. So therefore you can draw like this. So 2D packing, you can divide this one into 2 types. So first one is square closed packing. Okay, ma? And the next one is hexagonal closed packing. Okay. So here what is the type of void which is present? Cubical voids, or you can call it as square voids. So this is the type of void present here. And what is the packing efficiency, ma? Packing efficiency is equals to 52.4%. Clear, ma? And in the case of hexagonal packing, what is the type of voids we have? Triangular voids are present. Okay, ma? And what is their packing efficiency? Packing fraction is equals to 60.4% is the packing efficiency. Okay, so make a note up to here. Then we will study about 3D. Okay, Sima. So three-dimensional packing. In three-dimensional packing means what? Here atoms are present along lengthwise also, they are present along breadthwise also, they are present along depthwise also. In all the three dimensions you can find that. That is called as three-dimensional packing. Okay, ma? So in three-dimensional packing again we have two types. What are they? We can pack square closed packing also. We can use this one in 2D dimension. Similarly we can also use hexagonal closed packing also, again in 2D. Okay, ma? So we can use these two. So we can use a square closed packing also for packing in 3 dimensions. Similarly I can use hexagonal closed packing also for packing in 3 dimensions. So first of all let us study about first one, which is called as square closed packing. Okay, ma? Let us see how we can convert this square closed packing in 2 dimensions into 3 dimensions. Square closed packing we have studied in 2 dimensions. No? That one I want to convert into 3 dimensions. And how many different methods are there? Let us see. Okay. First of all, let us draw this figure. Drawing the figure is the biggest challenge here. Okay, ma? So, ఈ క్లాస్ కోసం 2 మార్కర్లు కూడా కొనుక్కొనొచ్చునా నేను. Okay. So this is a square closed packing, no ma? Square closed packing. Are you able to understand? So therefore, which type of voids are present here? Cube type of voids, or you can call it as square type of voids are present. Are you able to understand, no ma? Now in this square closed packing, first of all we will discuss about the first method. Okay, ma? First method. Which is the first method? First method is, see ma. So on this atom I can place one more atom, no? On the same atom I can place one more atom. How I can place? See ma, here black color indicates what? Black color indicates first layer. Okay, this is the first layer of atoms which are arranged in 2 dimensions. So on this one now I am going to arrange second layer also. దీనిపైన ఇంకొక లేయర్ అరేంజ్ చేస్తా ఉన్నాను. ఓకే, అండ్ దట్ ఐ విల్ రిప్రజెంట్ బై రెడ్ కలర్డ్ లేయర్. ఓకే, సో దేర్ ఫోర్ వాట్ డస్ రెడ్ కలర్ ఇండికేట్? సెకండ్ లేయర్. సో హౌ ఐ కెన్ అరేంజ్ ఐటమ్స్? నో దిస్ ఈస్ వన్ లేయర్. నో, above this one I will place another layer. So I am placing atoms like this. Are you able to understand? On the black colored atoms I am placing red colored atoms, but don't think atoms have any color. Just for your understanding I am saying. So this is second layer which I have placed. This is one type of pattern. Okay, ma? One layer, on that one there is one more layer. Black colored atoms, they are forming one layer in 2 dimension. On that one we are placing one more layer of red color atoms. Are you able to understand, ma? So it automatically it converted into 3-dimensional figure, no? Okay. Previously it was having length and it was having breadth also. Now it has a thickness also, no? Because on one atom we are placing one more atom. Are you able to understand, ma? And this type of packing we can call it as A packing. This is the name of this packing. Okay. What is meant by A packing? Okay. First layer is black color, no? First layer is black color. Second layer is red color. But arrangement is same type of arrangement, no? So the type of layer has not changed here. Arthamatunda? Type of layer has not changed. That is why this type of layer I can call it as AA. On that one you place third layer. On that one you place fourth layer. On that one you place the fifth layer. Type of layers they are not changing. That is why we call this packing as AA packing. Are you able to understand, no? So this is one type of packing. Okay. So right now. Clear? So therefore, chala careful ga vinandi. If you don't understand these basics, you cannot understand the higher figures. So therefore, what we write here, we write that the type of layers placed one over the other placed one over the other is not changing. Okay, so that is why it is called as AAA layer. Any number of layers you can place. Are you able to understand, ma? So one layer of black, one layer of red, one layer of green, any number of layers you can place. Okay, and what is the shape of the void? In 2 dimensions, if you say the shape of the void is remaining to be square shape, or you can call it as a tetrahedral shape also. If many layers you can place, then the same void it converts into tetrahedral shape. Are you able to understand, ma? That's it. Okay, so any other point here I have to discuss? Here, note point, very important note point you can make here. Note point is that, so the type of unit cell in 3 dimensions formed will be PCC. So this is the most important point. Are you able to understand? So if you are placing this type of arrangement, then the unit cell which is formed in 3 dimensions, what will be the type of unit cell, ma? Type of unit cell will be PCC. What is PCC? Primitive cubic cell. Are you able to understand, ma? And what is meant by primitive cubic cell? Atoms, they are present only at the corners. Atoms are not present at the center also. Atoms, they are not present at the face also. They are not present at the edges also. So if this type of arrangement we are placing, then the type of unit cell formed is PCC. And what is the packing fraction of PCC, ma? Packing fraction of PCC is how much? 52%. Okay, ma? So packing fraction of 3D unit cell is how much? It is 52%. Why it is 52%? Because here the type of unit cell formed is PCC only. No? Are you able to understand, ma? So this is one kind of packing. So then we study about the second method of packing in the same square closed packing. Clear, ma? Completed up to here? Okay. So second method of packing in what? In square closed packing. Are you able to understand, no? Which is the second method? Let us see. So first of all, let us draw the square closed 2D figure. So maintain the size of the atoms, then very easily you can draw the figure. So this is a square closed packing number. Each atom surrounded by 4 atoms. Now see. So again we draw the layers here. Black color layer indicates first layer of atoms, and red color indicates second layer. Okay, ma? And in this condition, how I can place this second layer is that I can place the second layer such that these voids, they are completely filled. Okay, ma? In the first case, on one atom we were placing second atom, no? Now in this condition, what we are doing, we are placing the atoms such that voids are covered. So this is one void which is present, no? So cover that void by an atom. So this is one type of arrangement. Okay, ma? And this is the second void, so this is the second atom. This is the third void, so this is my third atom. Okay, ma? So like this, if you are able to cover the voids, okay, then this type of arrangement is the second type of arrangement. Okay, ma? First layer is made up of black atoms, second layer it is made up of red atoms. Are you able to understand how we are packing? Are you able to understand? So what is the method we have used here? Method is that, so second layer is placed such that voids are covered. Okay, ma? Voids are covered in this condition. So this is the second type of arrangement in which type of packing? Square closed packing. In 2D packing we have two types of packing, no? One is square closed, second one is hexagonal. And again in a square closed packing we are studying two methods of 3D packing. One is atom placing on the same atom. Second one is atom placed on the only voids itself. Are you able to understand, ma? Therefore, the important note point here what I have to write is that, okay, ma? Important note point is, write down. Okay. So here the type of unit cell formed is BCC, body centered cubic cell. Are you able to understand, ma? So when you are placing the atoms such that it is covering the voids, okay, Then what is the type of unit cell formed here? The type of unit cell formed is BCC. Previously it was PCC, primitive unit cell, but here it is a BCC. What is meant by BCC? Do you remember?
Body center.
Ante em daya Subara. What is meant by BCC? No. Atoms, they are present at the corners. At 8 corners atoms are there. Similarly, there is one atom exactly at the center of the unit cell. So that is called as BCC. No? And what is the packing efficiency of BCC? 60? 64. I don't think. Packing fraction of BCC unit cell is how much? 68%. So therefore, if this type of packing is done, then you can form a BCC. And whose packing efficiency is how much? Packing efficiency is 68%. Okay, ma? So if packing efficiency is 68%, what is the void space? Void space is equals to 32%. Already we have studied, no? So this is the method of constructing a BCC, body centered cubic cell. Okay, ma? Place one layer of 2D atoms in square closed packing, and you fill the voids with atoms. Then automatically you will get a 3D space in which BCC atoms you can find, BCC unit cells you can find. Are you able to understand, ma? Okay. So next we take the hexagonal closed packing, and in that also we will study some types of packing. Okay, ma? So right. So what is the second type of packing? Second one is hexagonal Now see, so next we are studying about hexagonal 3D packing, how to do 3D packing with the help of hexagonal close packing. Are you able to understand, ma? Now see here, what is the shape of the voids which we saw, ma? So here there is one void, no? Marker zero. Kaduna. Okay. So here you see one void, no, ma? And what is the shape of this void? Triangular void in the form of a triangle. Here also you see one void, no? So this is also a triangular void, and this is another triangular void, okay? And this is also another triangular void. So what you understand? For example, if I draw a reference line, clear, no, ma? So if I draw a reference line, so that is if I draw an imaginary line like this, clear? Then what will be the shape of the voids which are created? This will be the approximate shape of voids, no, ma? This will be the approximate shape of the voids. Are you able to understand? So in the first layer of hexagonal packing, this is only first layer only, no? So atoms, they are arranged lengthwise, and atoms, they are arranged breadthwise, two-dimensional packing. But how many layers are there? Only one layer is present. Are you able to understand? So in that layer, you will get this type of voids. All the voids, they are triangular voids. Are you able to understand, ma? Now the point is that we have two methods of packing. Now this 2D figure I can convert into 3D figure in two methods. What is the first method, ma? First method is close the upper triangular void, okay, ma? Then lower triangular void cannot be closed. This is one method, okay, ma? And second method is exactly opposite to first one. Are you able to understand, ma? So can you say what is the meaning of the statement which I have written, ma? Ikkada em rasnano cheppandi chuddam. What did I write? See, ma, here I am getting triangular voids, no? One void is above the reference line and one void is below the reference line. So now see here, one method of closing is I can close this triangular void by an atom. Are you able to understand, ma? Then the bottom triangular void cannot be closed. This is one method. And the second method is, if you try to close the lower triangular void, then upper triangular void cannot be closed. Are you able to understand what is happening? So either you can close either the upper one or the lower one. So these are the two methods of packing. Okay. Now I will do one thing. I will place one atom on the upper triangular voids continuously. Okay. Now let us see how I can pack this one. Clear, ma? So I can pack it like this. So this is the method in which I can pack. Okay. Now here, what is the meaning of black color atoms, ma? Black color atoms indicates first layer. Okay, ma? And red color atoms, come on. Red color atoms indicates second layer of packing. Okay? And in second layer, how I am packing again? I am packing only the upper triangular voids. Lower triangular voids cannot be packed. Okay, they cannot be covered. Are you able to understand? Now see. Similarly, I will close this second one also. How can I close? Let us see. Okay, ma? So, this one I can close like this. Are you able to understand? Okay. And the next, this void, how can I close? Let us see. Okay, ma? And the next upper triangular void, I can close like this. Are you able to understand? అర్థమవుతుంది ఏం చేస్తున్నాము? All the black color atoms, they are forming the first layer, and all the red color atoms are formed the second layer. And we are closing which voids? We have two voids, no? So there is one triangular void above the reference line, and there is one triangular void below the reference line also. So which triangular void I am closing? I am closing the upper. You can close the down one also. That is your wish. Are you able to understand, ma? Okay. Now see here, this void which was covered, this void was covered, no, ma? This void will take the shape of, okay, ma, closed. I think it will not be visible, ma. So see, ma, here the void which is closed by an atom, this becomes closed tetrahedral void. It becomes closed tetrahedral void. Are you able to understand, ma? Winner. First listen very, very carefully. So here, one void I am closing, but one void I am not able to close, no? The void which is closed, that void will take which shape? That void will take the shape of closed tetrahedral void. Are you able to understand, ma? And the void which I was not able to close, so this is that void which I was not able to close, no? This void and this void. They will take the shape of, okay, ma, open octahedral voids. Okay, ma? They will take which shape? They will take the shape of open octahedral voids. Are you able to understand? So, మీరు close చేసిన void ఉంది కదా, that will take which shape? That will take the shape of closed tetrahedral void, because it is closed on one side. It is closed on top side also, it is closed on bottom side also. That is why it is called as a closed tetrahedral void. And the void which you are not able to close. Now see, in this void, this first atom also has taken some region. Second atom also has taken some region. Similarly, bottom atom also will take some region. So therefore, it will take which shape? It will take the shape of open octahedral void. Now there is no atom placed on this one, no? That is why it is open octahedral void. Are you able to understand, ma? Let us draw one more layer, some more atoms in this second layer, ma. So now see. Now here, can you say which are the voids which I have to close and which are the voids which I cannot close, ma? So this void and this void, they are above the reference, no? So those voids should be closed. So listen very, very carefully, ma. And what about this layer? This void is present below the reference, no, ma? So this void cannot be closed. Are you able to understand? So how to close this one? So I will close this one like this. Clear, no? Similarly, this void also should be closed, but this void cannot be closed completely. So therefore, the shape of the atom which I will draw is like this. Are you able to understand? Okay. So therefore, what about this void? What is the shape of this void, ma? Chappan tondarga, huh? Closed tetrahedral void, because it is already closed, no? Now what about the void created here? This will become the shape of open octahedral void. This is what is happening. Are you able to understand? And once you see here also there is one more void which is created, no, ma? This void. What about this void? Is it present in the first layer or is it present in the second layer? This void. This void is present between red color atoms, no? Ee void ekkadundi? It is present in between red color atoms. It means this void is present in the second layer. Okay, ma? And the shape of that void will be, it is called as open tetrahedral void. Are you able to understand, ma, what is happening? So we are discussing about three voids here. One void is a closed tetrahedral void, another void is open tetrahedral void, and the third void is open octahedral void. Are you able to understand? Now can you say where this, we will revise once again. Where is this open octahedral void present, ma? It is present in the second, Open octahedral void. It is present in the first layer, in between first layer and second layer, and it is that void which is not covered by an atom. Understood, no? And what about a closed tetrahedral void? It is the void which is present in between first layer and second layer, but it is covered by an atom. Are you able to understand? Then what about open tetrahedral void? It is the void which is present in the second layer, and where this red color, the gaps between red color atoms is nothing but open octahedral void. Are you able to understand? So make a note of that point. Clear now? So if a void in first layer, okay ma, is covered by, is which void? Triangular void. If triangular void in first layer is covered by atom, then which kind of void will be created? Then closed tetrahedral void will be formed. Are you able to understand ma? Void will be formed. Okay. Then if a triangular void in first layer is not covered, it converts into what ma? It converts into open octahedral void. Open octahedral void. Understood, no? And the void in the second layer, is will be which type of layer ma? Will be open octahedral layer. Open octahedral voids. So understood now which type of void is formed by closing one void? You are able to understand now? So these are the three types of voids which are formed by forming the second layer. Are you able to understand? Okay. Completed up to here? Brian, make a note up to there. So one more point which I can write is, make a note point. One note point is that, okay, so for every n atoms of second layer, okay ma, so 2n which voids? 2n tetrahedral voids, okay ma, and n octahedral voids will be formed. Are you able to understand ma? So if you are placing n atoms in the second layer, then how many tetrahedral voids can be formed ma? 2n tetrahedral voids can be formed. It means double number of tetrahedral voids. And in this tetrahedral voids, 1n will be open and 1n will be closed. Clear no? And how many octahedral voids will be formed? N octahedral voids will be formed. Are you able to understand? So this is a point which you should understand. Okay? Completed ma? Now see ma. So therefore in this after forming second layer, and which is the second layer, red color atoms, they will form the second layer. Okay ma? So after forming the second layers, we have discussed about three types of voids, no? One is open tetrahedral, second one is closed tetrahedral, and the third one is open octahedral. So in the name only you can see nama closed tetrahedral, it means it is already closed. Now how many voids are there for closing? Two voids are available for closing. Are you able to understand? Now see. So therefore I am rubbing all of this. So in three types of voids formed, okay ma? In three types of voids formed, closed tetrahedral void is already closed. Okay ma? So it means on this void already we have placed an atom. So this is already closed. Okay? We have two voids that can be closed. Okay ma? Now what are the two voids by which I can close those voids by placing atoms ma? Two voids are there. What are the two voids? One is this one. Which is this one? Open octahedral void. And the second one is open tetrahedral void. So these two voids are available for closing. Are you able to understand? Now see. So first one, placing third layer, okay ma? Placing, I think not visible, placing third layer on open tetrahedral void, okay ma? Open tetrahedral void. Now there are two methods in which I can place the third layer, no ma? Two methods. What are the two methods? Either I can place the third layer on open tetrahedral void, or I can place on open octahedral void. Two methods are there. Okay. So we are discussing about the first method. Now two layers already I have placed, no ma? Now I want to place the third layer. Okay. So where is the third layer? See ma, I want to close this void, no? What is this void? Open tetrahedral void. Placing third layer on open tetrahedral void. Okay ma? And the third layer I will represent by green color. Third layer represented by green color. Are you able to understand ma? So if I want to close this void, so this is the atom which I have to place. Are you able to understand ma? It means on the black atom only I am circling this green color pen, no ma? On the black atom only I am circling the green color pen. So what do you understand? If I want to close this void, which is open tetrahedral void, again I have to place a third layer. And third layer is exactly symmetrically placed on which layer? It is symmetrically placed on black atom, which is the first layer. Are you able to understand ma? It means that in the third layer, first layer is again repeated, no? Arthamatunda? I want to close which void? I want to close open tetrahedral void. It means I want to close this void. If I want to close this void, I will place a green color atom. Don't think atoms are green, just for your information, okay ma? I am supposed to place a green color atom. And that green color atom, symmetrically it is placed on which layer? Exactly it is placed on first layer, no? Are you able to understand ma? So therefore what happens is, here, okay ma? First layer is again repeated. First layer is again repeated. That is what will happen, no? Okay ma? So therefore, type of layers will be A, B, A, B, A, and it goes on like this. Okay? Can you say why I have written A, B, A, B, A, B ma? A is the first layer. B is the second layer. In the third layer, again it is repeated, no? So again layer will come. So that is why the type of layers created will be A, B, again A, B, again A, B, like this. Are you able to understand ma? And here the type of unit cell formed is, okay ma, hexagonal unit cell. This is the most important point. Are you able to understand ma? So here what is the type of unit cell formed by placing this third layer ma? Hexagonal unit cell will be created. Okay ma? Hexagonal unit length means it will have how many sides? 6 sides will be there. Previously we studied only cubic, no? Cubic means it will have a different construction is there for cubic. Okay? So how many faces? Totally 6 faces will be there. Are you able to understand ma? And 12 edges will be present. But here the type of unit cell created is called as hexagonal unit cell. So you can call it as HCP also. Are you able to understand ma? So this is the type of unit cell created in which condition ma? When atom is placed where? Third layer where you are placing? Third layer you are placing on open tetrahedral void. That is the condition. Understood no? Come on, make a note up to here. Okay, now see ma. So there were two methods of closing the two voids, no ma? First method of placing the third layer was placing atoms on open tetrahedral void. Then the type of unit cell formed was what? Hexagonal unit cell. And what is the second method of closing the same which void now I have to close ma? I have to close open octahedral void I have to close. Are you able to understand? Now see. So placing third layer on open octahedral void. Okay ma? Open octahedral void. Now where is octahedral void? Here there is an octahedral void, no ma? This is an octahedral void, no? Are you able to understand? Let us close this one. And fourth layer, again I am representing by black color atoms ma, because I have only 3 pens only. Clear ma? So black I am representing by third layer only. Okay, this is one method of placing the third layer. Now we are discussing second method of placing the third layer. Are you able to understand? Now this atom where I can place, I have to close this open tetrahedral void. This void I have to close. Now let us see how can I close this one. Okay, so this is the method in which I can close this open octahedral void. Okay, now can you see any layer, is it repeated? First layer, second layer, is any layer repeated here? No layer is repeated. Are you able to understand? So that is the first point we have to write. So here layer is not repeated. Okay, layer repeat avaledu. It means that new layer is formed. New layer is formed. Are you able to understand? So therefore this type of arrangement is called what? This type of arrangement, what you call this type of arrangement you will call ABC type of arrangement. Okay, now can you say what is meant by ABC type of arrangement? First layer is A, the layer of black color atoms. Second layer is B, the layer of red color atoms. Third layer is C, or you can say another, again black color only is repeating, but it is not equal to first layer. Okay, see, this third layer, it is not placed either an atom of first layer or an atom of second layer. It is completely a new layer. Are you able to understand? That is why it is called as ABC. After that again A will repeat. After that again B. After that again C will repeat. So this is the type of arrangement. Are you able to understand, And here the unit cell formed is, okay, here the type of unit cell formed is, okay, which type of unit cell is created here? FCC. Face centered cubic unit cell will be formed in this condition. Are you able to understand? So if you are placing atoms on open tetrahedral void, what is the type of unit cell created? Hexagonal unit cell is created. But when you are placing atoms on open tetrahedral void, then what is the type of unit cell created? FCC. And what is meant by FCC, can you say? Atoms, they are present at the corners, and there is an atom exactly present at the center of each face also. That is called as an FCC. Are you able to understand? So this completes our topic, which is called as packing of crystal in 1 dimension, 2 dimension and 3 dimension. Are you able to understand? Make a note up to here. అర్థమవుతుంది కదా ఏ atom ఎక్కడ ప్లేస్ చేస్తే? Okay, so now we will have discussion on voids. How many voids will be there? What is the position of the voids? Okay, all this we will discuss here. Okay, so types of voids, how many types of voids we have studied? Triangular voids, tetrahedral voids, octahedral voids and cubical voids. These are the type of voids which we have studied. So where a triangular void will be created? Position, can you say? Position is triangular void. So in the first layer of hexagonal close packing in 2D. This is the position, do you remember? When atoms, when they are placed in 2D dimension, and in which type of arrangement? Hexagonal close packing. Then what was the type of void I got? Then the type of void which I got was triangular void. Are you able to understand, Okay, so the radius of atom that can be placed on void is given by radius of void is equals to 0.155 radius of the atom. So this is a very, very important discussion. So if I want to close that void, which void? Triangular void. Are you able to understand? Then RV means what? Radius of atom placed on void. What is the radius of the atom that should be placed on the void to close that void? And it is equals to how much? 0.155 times of radius of the atom. What is meant by radius of the atom? Original atoms by which this void was created. Are you able to understand, So see, one more discussion I can write here. Same RV can be written as R plus also. I can call it as a cation also. And this is equals to 0.155 times of radius of anion. Okay. So why I am calling the radius of the atom which can be placed on the void to be a cation? So I want to close which void? I want to close triangular void. Then what is the radius of atom I have to place? This one. RV is equals to 0.155 times of RA. What is RA? radius of original atoms by which triangular void was formed. Are you able to understand? Or if you want to draw a figure, Sima. So this is RA, radius of the original atom. Okay? And in hexagonal packing, here I will get a triangular void number. So on that triangular void, what can be the radius of the atom I have to place? This is the radius of the atom I have to place. Okay? And that radius is given by RV. And this is the dot. Atom placed on void. Are you able to understand? And what is its value? Radius of the atom which can be placed on the void is how much? 0.155 times of radius of the atom by which this triangular void has been created. That is the meaning of it. And these values also there is some calculation, but we don't go for calculation, just by heart these values. Okay. Now see, listen carefully. So the size of the atom or radius of the atom which can be placed on the void, I have represented by R plus, radius of the cation. Why? Why is it like that? Because it is very smaller in size, no? When compared to radius of the atom which is creating this void, the radius of the atom placed on the void is very small. And generally cation sizes will be very small, no? In periodic classification we have studied, no? What is meant by cation? The atom, when it loses electron, it will become positively charged. And what happens to its size? Increases or decreases? Decreases. Why size decreases? Because the net force of nucleus on the remaining electrons increases. And automatically size will decrease. Or in another method, how can I say? Once it has lost an electron, it doesn't want to lose another electron, so it will reduce its size. Are you able to understand? So point is that radius of the atom which can be placed on the void, it is smaller, no? So that is why it is represented by R plus, and the radius of the atom by which this triangular void is created, that is represented by anion, R minus, because it is bigger in size. Is it clear? That's it. Now let us have a discussion on tetrahedral voids. Okay, ma? Where tetrahedral voids were created, ma? Okay. So position we will discuss. Position. Where is the position? Okay, ma? So closed tetrahedral voids were created because of second layer in HCP, hexagonal close packing. Already we have discussed, no? Triangular voids, if you close them by an atom, then what is the type of void created? Closed tetrahedral void. That is the void which is created, no? Are you able to understand? And open tetrahedral void. Open tetrahedral void was present where? Was present in second layer of HCP atoms. Do you remember? Red color layers we have drawn, no? In between that red color layers only we were seeing this open tetrahedral void. That is the position of tetrahedral voids. Okay, ma? Open tetrahedral as well as closed tetrahedral voids. Okay. And here, where these tetrahedral voids they are present inside the unit cell, that also we will write. Okay, ma? So tetrahedral voids are present at a distance of d by 4 on the body diagonal from corner. Okay, ma? So this is the arrangement of tetrahedral voids. And this position you are supposed to by heart, because if you try to understand, I don't think it is possible. Are you able to understand more? So where tetrahedral voids they are present, ma? Tetrahedral voids they are present at a distance of d by 4 on body diagonal. How many body diagonals will be there for a unit cell? Body diagonals are not 4 body diagonals will be there. Okay, ma? Each body diagonal will have 2 tetrahedral voids. At what a distance? At a distance of d by 4 from the corner. Okay. I will do one thing, ma. I will draw the figure here. So you write below this one. I have no space now. I am writing here. So therefore consider this is a unit cell, cubical unit cell. Are you able to understand, ma? So totally how many body diagonals will be there, ma? So this is one body diagonal, and this is one body diagonal. Clear, na, ma? And this is one body diagonal, and this is one body diagonal. So 4 body diagonals will be possible. Are you able to understand? And where is its position? Position is here. Here there is one tetrahedral void, and here also there is one tetrahedral void. And what is this distance? This distance is d by 4. Okay, ma? And each body diagonal will have 2 tetrahedral voids. Are you able to understand? How many body diagonals are present? 4 body diagonals will be there. Each body diagonal will have how many tetrahedral voids? 2. So total tetrahedral voids? 8. 8 tetrahedral voids will be present. Are you able to understand now? So make a note of it. So this is the position of tetrahedral voids. Are you able to understand? So write down. So each body diagonal will have 2 tetrahedral voids. Okay. Total how many body diagonals? 4 body diagonals. Clear, no? Therefore, total tetrahedral voids are how many? 4 2s are 8. And this is in which case? This is in the case of FCC, face-centered cubic unit cell. Okay. So in FCC, how many tetrahedral voids will be present? 8 tetrahedral voids will be present. Are you able to understand? And there is a relation between HCP and FCC. So this is the relation. So hexagonal unit cell, or you can call it as hexagonal closed packing, this is equals to 3 by 2 times of FCC. Therefore, number of voids in hexagonal unit cell. And you should remember when this hexagonal unit cell was formed. Hexagonal unit cell eppudu form ayindi? Cheppandi. When open tetrahedral void was closed, then you got this hexagonal unit cell. So number of voids in hexagonal unit cell is how much? 3 by 2 times of FCC. Clear, nama? 3 by 2 times of how many tetrahedral voids are present in FCC? 8. So 3 by 2 into 8 is how much? 12. So 12 tetrahedral voids are present in which type of unit cell? Hexagonal unit cell. Okay. And how we got this relation, you need not understand, you have to by heart it. Understood, Nama? That is the discussion. Arthamavutundi kada? Make a note up to here. Okay, ma? Now see the positioning and number of voids which can be possible in which kind of voids? In octahedral voids. Now can you say how they are formed, ma? Formation. How they are formed? Come on. When second layer of HCP was not covering triangular voids. Okay, ma? So 2 types of arrangement we have studied, no? Either we can close the top triangular voids or bottom triangular voids. When top triangular voids was created, bottom triangular void it has converted into octahedral void. This is the arrangement of octahedral void. Are you able to understand, ma? And so ma, here I think I have forgot one point. Point is that, write down. In tetrahedral void, radius of atom which can be placed on the void. What is meant by RV, ma? RV means what? Radius of atom which can be placed on the tetrahedral void. This is equals to 0.225 RA. Okay. What is meant by RV, ma? Radius of atom that can be placed where? That can be placed on tetrahedral void. Okay. And what is meant by RA? Radius of that atom which created this void. Difference arthamavutundi kada? Or in terms of cation and anion you can write R plus is equals to 0.225 or minus. So you can write like this also. Okay. Because in a crystal, if one is a cation, another one should be anion. Are you able to understand, ma? That's it. So now see, octahedral voids. When second layer of HCP was formed, was not covering triangular voids, then this octahedral void was created. Okay. Now where is its position? Position is, it is present at the center of edges. It is present at the center of edges and exactly at the center of unit cell. Are you able to understand? Okay, ma? Now see ma, here one more discussion we have to do here in tetrahedral voids. See ma, so totally how many tetrahedral voids are present in FCC ma? 8 tetrahedral voids are present, no? And all of them, they are present inside the unit cell, no? All these 8 tetrahedral voids, where they are present? Inside the unit cell. So therefore, what is their contribution? How much percent will be the contribution? 1 by 4, 1 by 2, 3 by 4, how much?
1 by 8.
Contribution will be 100%. Contribution will be 1. What is the reason? Because these voids, they are completely present inside the unit cell, no? Okay, ma? For example, if an atom is present at the corner, then this atom can be shared by how many unit cells? 8 unit cells. That's what we have studied, no? If there is an atom present on the corner, then this atom can be shared by how many unit cells? 8 unit cells. So this, therefore, contribution was only 1 by 8. That was what we have discussed in the first class, no? Okay. But these voids, tetrahedral voids, where they are present? They are present inside the unit cell. So therefore, total void is present inside only, no? So contribution will be how much? 100%. So you can make a note of that point here. Clear, ma? So below this one, make a note point. What is the note point I have to write? All tetrahedral voids are present, okay, ma? Where? Present inside the cell. Okay? Therefore, their contribution is how much? Their contribution is 100%. Okay? So if 8 tetrahedral voids are present, all the 8 will be there inside the unit cell. If 12 tetrahedral voids are present in HCP, all 12 will be present inside the unit cell. Are you able to understand? But here the discussion is quite different. Now see. So where is the position of octahedral voids, ma? It is present at the center of edges and exactly at the center of the unit cell. Let us draw the diagram. First make a note of this point. Completed, ma? Now see. Now by looking at this statement, can you say what is the meaning of this one, ma? Ekkadunnayi octahedral voids cheppandi. Where is the position of octahedral voids, ma? So I will draw the unit cell. So this is the unit cell which is created. Clear, no, ma? So octahedral voids, they are present at center of edges. Which is an edge here? This is one edge, no, ma? Clear? So like this, how many edges will be present? How many edges will be present in a cube?
8.
Edges. 12 edges will be present. Are you able to understand, ma? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges will be present. Okay? So 12 octahedral voids will be present on that particular unit cell. Are you able to understand? And one more location is that. What is that one more location? Exactly at the center of the unit cell, one octahedral void will be present. So exactly at the center of this, what you call unit cell, one octahedral void will be present. Okay? So therefore, now can you say what is the contribution of the void which is present on the edge? If there is a void present on the edge lo unte, then how much void will be present in one unit cell? Oka unit cell lo enta contribution untundi? 1 by 4. 1 by 4 already we have studied, no, ma? When atoms, when they are present at the edges, that edge can be surrounded by 4 atoms, 4 unit cells. Okay? So therefore, totally how many edges are there, ma? So totally 12 edges. Okay, ma? And contribution is 1 by 4. Therefore, octahedral voids on edges. Total will be how much, ma? It will be 1 by 4th of 12. 1 by 4th of 12 is how much? 3. That is the meaning of this one, no? It means this unit cell will comprise, totally it will accommodate how many octahedral voids? 3 octahedral voids. Are you able to understand? Okay, ma? And there is one void exactly at the center, no? And what will be its contribution? 100, because it is totally present inside, no? So 3 plus 1? 4. So 4 is the number of octahedral voids that can be comprised of FCC, face-centered cubic unit cell. Clear, no, ma? So write down. And contribution of octahedral void at center is how much? 100%. Therefore, total number of octahedral voids will be how many? Okay, ma? Therefore, total number of octahedral voids is how much? 3 plus 1, it is equal to 4. And this is the value in FCC, face-centered cubic unit cell. Okay, ma? If it is the value in FCC, then what will the value in HCP? HCP, what is the relation we have written? HCP is equals to 3 by 2 times of FCC. So 3 by 2 into 4 is how much? 6. So therefore in hexagonal unit cell or hexagonal close packing, how many octahedral voids will be present? 6 octahedral voids will be present. Are you able to understand more? So this is the easiest method of remembering the number of voids which are present in different locations. Okay? Time on the అయిపోయిందా? ఎక్స్ట్రా అయిపోయిందా? క్యూబికల్ వైడ్స్ ఒకటి చెప్పేద్దామా? వద్దులేండి, రేపు డిస్కస్ చేద్దాం. ఓకేమా? So in the last class we studied about 3 types of voids, no, and their contributions, everything, positions and how they are formed, everything we have studied. Ma. So the last void is cubic void. So where this cubic void will be formed? Ma? Cheppandi. Cubic void, where it will be formed? Okay, ma? It is formed in square close method or square close packing. Are you able to understand, ma? And what is meant by square close packing, do you remember, ma? When one atom is placed exactly below one more atom, then this type of packing you can call it as square close packing. So this is where we got this cubical void, no? Clear, no, ma? And here, what is the radius of the atom which I have to place on the void so that I can cover this void? Okay, ma? So here I have this void, no? What is the shape of this void? Cubical void or cube void. So on this void, if I want to place an atom, then what is the radius of that? That radius of the atom is given by RV is equals to 0.732 times of radius of that. And what is meant by RV and what is meant by RA already we have studied, no? RV means radius of that atom which should be placed on the void to cover that void. And RA is the radius of the original atoms which is forming that void. That is the condition. Understood, Dhamma? So that's all. About cubic void, this is the only point which you should remember. Okay? Make a note up to here. Sima. So question is, atom of element B, it is forming FCC lattices and element A is occupying 2 by 3rd of tetrahedral voids. Clear, Nama? And atom C is occupying 3 by 4th of octahedral voids. Then what is the formula of this compound? This is the question. Okay, ma? So previously also we have done some problems based on what is the formula of the compound, no, ma? There, do you remember what is the method we have adopted, ma, to calculate formula of the compound? Now, ratio of what? Ratio of different atoms of what? Ratio of number of atoms by mass. That's what we have taken, no? Ratio of number of atoms by mass which are present at different positions. Okay? That ratio itself will give the ratio of the element. That's what we have studied, no? For example, if you take the atoms which are present on corners. How many atoms are present at corners? 8. Then what is its contribution? 1. Are you able to understand? Because 1 by 8 into 8 is 1. Because contribution is 1 by 8, no? So 1 by 8 into 1 is 1. So if all the atoms, if they are present at the corners, it means actually one atom is present inside that particular unit cell. That's what we discussed, no? If atoms, if they are present at the centers of phases, then for example, if one atom is present at center of the phase, then what is its contribution to that particular unit cell? 1 by? I am saying phase center. Phase center. 1 by 2 is the contribution. Okay, ma? How many phases will be there? 6 phases. So 6 into 1 by 2? 3. It means that unit cell is enclosing 3 atoms. Are you able to understand, ma? So the ratio will become 1:8. If atoms are present at the corners, 1 atom is enclosed, no? If atoms are present at the phases, 3 atoms are enclosed. So total 1 plus 3, 1 plus 3 only, na? 1 plus 3, 4. Or you can say the ratio of elements is 1:3. Like this we have taken the ratio, no? Here also same concept. Are you able to understand, no? So let us write that concept once again. So formula of compound depends on number of atoms by mass, okay, ma? enclosed by unit cell. This is the method which we have adopted, no? So here also we will adopt the same method. Okay, ma? So see here, what is the type of lattice given? FCC lattice, face centered cubic lattice. Understood, ma? And who is present at FCC lattices, ma? B. element B is present. Okay, so therefore listen very carefully, then you can write down. First listen. So B element is present. Are you able to understand? So in B element, where it is present in FCC. Now can you say, if all the elements, if they are present on FCC, then this unit cell is enclosing how many atoms of B? Can you say 4? How you got this 4? 4 allowed in Japan. In this total FCC lattice, it is equivalent as if this FCC is enclosing 4 atoms of element B. How can I say it is 4? Gurtunda yadanna? Yes. So at the corners there are 8 atoms. What is meant by FCC? 8 atoms are present at the corners. 6 atoms they are present at the faces. That is meant by FCC lattice. No? So therefore total contribution is how much? 1 by 8 into 8 plus 1 by 2 into 6. That's all, no? Because when they are present on the face, then its contribution is only 50% to that particular unit cell. Already discussed cheskunnam manam. So therefore 1 plus 3 is how much? 4. So it means that this particular unit cell is enclosing how many atoms of element B? 4 atoms it is enclosing by mass. Up to here it is clear, no? Then you see element A. Element A is occupying 2 by 3rd of tetrahedral voids. Okay, ma? So A element or atom of element A, here also FCC only. Are you able to understand, ma? And how many voids it is covering, ma? 2 by 3rd of tetrahedral voids. Okay. Now in a third of 8 is how much, ma? 2 by 3rd of 8, let it be 16 divided by 3. So these are the tetrahedral voids present in FCC. Are you able to understand, ma? So therefore 16 by 3 atoms are enclosed by this particular unit cell. That is the meaning of this one. Are you able to understand, ma? And B element, which is the last element, ma? C element. Atom of or atoms of a C element, it is enclosing how many voids? 3 by 4th of octahedral voids. Are you able to understand, ma? So in FCC only, how many octahedral voids will be present? Octahedral voids. In FCC, octahedral voids, ma? 4. Octahedral voids. FCC octahedral, 4 only, correct. Okay, ma? So 3 by 4th of 4. That's all, no? So octahedral voids in FCC they are 4 and they are 6 in HCP, hexagonal close packing. 4 is correct. Clear, ma? So total how many? 3. Okay. Now you take the ratio of ABC. Ratio of ABC is nothing but formula of the compound. Clear, ma? So therefore A is to B is to C is how much? So which is the first one, ma? A I will take 16 by 3. You can take B is to A is to C, also anything you can take, no problem. 16 by 3, A, B is 4. And what about C, ma? C is 3. Correct only now what we are doing. So if you do this calculation by 9, so 16 is to 12 is to 9. Clear, na, ma? History lekkal kuda cheyalekapothe etra meeru. Okay, see, ma. So in a solid, అంటే వీళ్ళ తప్పు కాదు, ఇంతకుముందు వీళ్ళకి టీచ్ చేసినట్టు లెక్చరర్లు అద్భుతమైన టీచర్స్ అంతా కెమిస్ట్రీ. ఆ దరిద్రం వద్దని నేనే చెప్తా ఉన్నా, అదే విషయం. ఓకేమా? సో ఇన్ అ సాలిడ్ ఆక్సైడ్ అయాన్స్ ఆర్ అరేంజ్డ్ ఇన్ CCP manner. CCP manner is nothing but FCC, ma. Phase cubic central atom. Clear, no, ma? So oxide ions means what? O2 minus, no, ma? O2 minus. So they are arranged in which arrangement? In FCC arrangement. CC means closed cubic packing, ma. Closed cubic packing. Are you able to understand? Equivalent to, so in CCP only you will get FCC. Are you able to understand? So O2 minus in FCC. So FCC atom will enclose how many oxygen atoms, can you say? 4. Already we have calculated in the last problem only, no, ma? So total oxide ions, they are forming which structure? Phase central cubic structure it is forming. Are you able to understand, no? It means that in FCC how many O2 minus atoms can be packed? 4 atoms by mass. Already we have calculated, no? Okay. Then you see about cation A. Okay, ma? So this is anion, no? It means 2 cations are required because it is O2 minus. So there is one cation of B atom, there is one more cation of C atom. That's what he gave, no? No, A and B he gave. Okay, whatever it may be. So cation A is occupying which place? It is occupying 1/6 of tetrahedral voids. Understood? No? And how many tetrahedral voids are present in tetrahedral voids in FCC? 8. Clear, Nama? So 8/6 is how much? 4/3. మొత్తానికి కలిపి చేయాలయ్యా సుబ్బారావు, ఒకదానికి రావచ్చు రాకపోవచ్చు. క్లియర్ నవా? సిమిలర్లీ cation B. Cation B is occupying what? It is occupying 1/3 of octahedral voids. Clear, no? So 1/3 of how many octahedral voids are present in FCC? 4. Clear, no? So therefore what is the ratio again? Again it is 4/3. So therefore to take the total ratio, O2 minus is to A is to B is equals to 4 is to 4/3 is to 4/3. Clear, no? So therefore multiply everything by 3. 12 is to 4 is to 4. Okay, ma? And divide everything by 4. So 3 is to 1 is to 1. That is my answer. అసలు ఏమన్నా ఉందా అది మరి? Sima. This is an important table describing about the ratio of cation to ratio of anion. What is meant by ratio of cation to ratio of anion? Already we have discussed previously. No, RV is equals to some value multiplied by RA. Already we have studied. No? Okay, ma? And when this RV can also be written as R plus also, because void is always smaller. No, void is always smaller. On that void, the atom which you place, that also will be smaller. So the atom which we place on void is taken as cation, positively charged particle. Understood? No? And this is the radius of the anion, you can call it as, or radius of the atom which is forming that particular void. అర్థమవుతున్నాయి కదా ఏ టర్మ్ దేనికి సంబంధించిందో? So therefore I can write that RV divided by RA, this is also equal to R plus divided by R minus. So it will have some range of values. Yesterday we have written some values, no, they were minimum values. Yesterday the values which we have written, they were minimum values, but a range of values can be present. Okay, ma? Arshia sunte nahi tumhe. So range of values means what? There will be one minimum value, there will be one maximum value also. Yesterday we have written values. No? What are the values we have written? 0.155, 0.225, 0.414, 0.732. These are the values which we have written. Okay. But if you see trigonal void, then the ratio of the cation to ratio of anion, it will be ranging from 0.155 to 0.225. But it cannot be 0.225, less than 0.225. Are you able to understand? Because 0.225 is the void, is the atom which is related to tetrahedral. So on the tetrahedral void, what can be the ratio of the atom which I can place? 0.225 to 0.414. So this is the minimum value and this is the maximum value. Understood, Nama? Similarly, for octahedral, 0.412, next void, which is the next void, cubical void, and for cubical void, which is the minimum value, 0.732. Okay, so you can pack this one up to 0.731, but not 732, because 732 is related to cubical void. Are you able to understand, Nama? So in between these ranges, any atom you can place on these particular voids. That is the meaning of this one. So these ranges you should remember, because in the questions he will ask what is the maximum value of cation and what is the minimum value of cation. Then if you remember this range, then only you can do such type of problems. Okay, minimum range means this one, maximum range means this one, that's it. Okay, and for cubical void it is 0.732 to 1. Are you able to understand, ma? And coordination number, what is meant by coordination number? Already we have studied. No, coordination number means the number of atoms which can be surrounded and which are present at the shortest distance. That is called as coordination number. Okay. For trigonal or triangular voids, what is the coordination number? 3. For tetrahedral, coordination number is 4. Octahedral, it is 6. And for cubical, it is 8. And those are the examples. Are you able to understand? So make a note of this diagram. Then we will do some problems on this ranges, ma'am. Okay. See, ma'am. So let us see this question. A solid having formula AB, cation A occupies octahedral void. Okay, ma? So question is given on what? Question is given on octahedral void. Okay, ma? And in octahedral void, what is the range of radius of cation to radius of anion? Range చూడండి పుస్తకాల్లో, నన్ను చూస్తారేమే 0. So range is 0.414 to 0.732. It means this is the minimum value, no? and this is the maximum value. Now see, so if anion B has, okay ma, and what is this ratio ma? This ratio is nothing but R plus divided by R minus ratio. Okay, so R plus value is already given. R plus value is R minus value is how much? 241.5 picometers. Okay, then what should be the minimum radius of cation? That's the question, no? Minimum radius I want. It means I can write this relation R plus is equals to some value multiplied by R minus. This is the formula, no? So if R plus should be minimum, because he is asking minimum value of cation, no ma? So if R plus is minimum, the value here present also should be minimum only. So out of these two, which one shall I select? Minimum on telusu kada? So 0.414. Okay ma? So just substitute R plus is equals to 0.414 multiplied by what is the radius of cation ma? Anion ma? 241.5. So just to do this calculation, that will be the radius of the cation. That's all. అసలు ఏమన్నా ఉందా ఇక్కడ? అంటే మన బుర్రలో కూడా ఏం లేదు అని అర్థం. ఏం లేదు, గుజ్జే లేదు అసలు. ఓకేమా? సో 99.98 picometers. So that is the minimum value of cation that can be placed on this octahedral void. That is the question. Understood, no? Minimum ఇంత రేడియస్ అన్న మీరు ఆ వాయిడ్ పైన పెట్టాలి. ఓకే ఓకే సీమా. So let us see this question. So predict the coordination number of My atoms in My crystal if ionic radius of M plus and Y plus are 97 picometer and 251 picometer. Okay ma? So see, so already we have studied that radius of plus is equals to dash of radius of minus. This is what we have studied now. So if you get this value, then you can predict it is belonging to which type of void. ఇక్కడ ఏ టైప్ ఆఫ్ వాయిడ్స్ ఉంటాయో ఫస్ట్ మీరు అది ఐడెంటిఫై చేయొచ్చు. అండ్ వెన్ యూ క్యాలిక్యులేట్ ద టైప్ ఆఫ్ వాయిడ్ అండ్ ఫర్ ఎ పర్టికులర్ వాయిడ్ ఆల్రెడీ వీ హ్యావ్ రిటర్న్ ద కోఆర్డినేషన్ నంబర్స్, నో? Are able to understand ma? So do the calculation. So R plus divided by R minus is how much? R plus value is how much ma? 97 picometer. R minus value 251 picometer. Okay, picometer will get cancelled. So 97 by 251 is how much ma? 100 divided by 300 approximately 0.3 something we will get, no? Where is that? 0.3864. 0.3864. Okay. Now you see this is the ratio of cation and anion which we got, and 0.3864 will lie in which range? It will lie in the range of what? 0.225 to 0.414. That's all. ఈ రేంజ్లోనే ఉంది కదా అది. Okay ba? So it is lying in this range, and this range belongs to which void? Tetrahedral void. So that is my answer. Okay ma? Tetrahedral void. And tetrahedral void coordination number 4. That is my answer. That's all, no? So coordination number will be 4 for this particular crystal. So the last topic which we are studying is ionic crystals ma. So in ionic crystals we have two types of crystals ma. Crystals means the combination of cations and anions only, no? Clear number? Cations and anions, how they are arranged, that we are studying. So these ionic crystals, they may be in the ratio of 1:1. It means for every one anion there may be one cation, and they may be present in the ratio of 1:2 or 2:1. That means for one anion there will be two cations, or for one cation there will be two anions. Are you able to understand ma? So these are the possibilities which we have. And in 1:1 ratio, which is called as AB type, these are the examples which we study. Okay ma? So NaCl, CSCl, ZnS. And 1:2 ratio, we will study CaF2 and Na2. Okay? It means for one Ca2 plus, there will be two F minus ions. Are you able to understand ma? So these are the models which we are going to study now. So once we complete them, then it will be completion of our topic called solid state. Understand? Now see. So the first crystal which we will study is NaCl crystal. Okay ma? We are going to study about this crystal. So features of this crystal are, okay ma, each Na plus ion is surrounded by is surrounded by 6 Cl minus ions and vice versa. Are you able to understand, ma? Each sodium ion will be surrounded by how many chlorine ions, ma? It will be surrounded by 6 chlorine ions. And what is meant by vice versa? Each chlorine ion also is surrounded by 6 sodium ions. Are you able to understand? So therefore, can you say what will be its coordination number, ma? Therefore, coordination number of NaCl, can you say? 6 is the coordination number. And what is meant by coordination number? Already we have studied, no, ma? What is meant by coordination number? How many atoms are surrounded by a particular ion in the shortest distance? So how many are surrounded? 6 are surrounded, no? Subara. Namaskar. Vinali. Are you able to understand, ma? So each sodium, it is surrounded by 6 chlorine. And each chlorine is also surrounded by 6 sodium ions. So therefore its coordination number will be 6. Okay, ma? Now let us see the arrangement of this ions, ma. Okay? Where this sodium and chlorine ions, they are arranged in this crystal, that we will study. So listen very carefully. Listen, ma, first of all, then you can write down. See, ma. So Na plus ions, so sodium cations, where they are present on all octahedral voids. Where they are present, ma? On all octahedral voids, you can find this Na plus ions. Okay. Now can you say, in a cubic crystal, what is the arrangement of octahedral voids, ma? Cubic crystal lo octahedral voids ekkada untayi cheppandi? In the table, huh? In the middle of cubic cell. Very good. Still in the middle of one cubic cell there will be one octahedral void. Still where there will be present? They will be present on the center of each edge. Student, previous note students, octahedral voids arrangement student ekkada unnayo? Are able to understand, ma? So therefore they are at, okay, ma, centers of each edge. Okay, ma? At every edge you can find Na plus ions. So totally how many edges are there? There are 12 edges, no, ma? For a cube, how many edges will be there? 12 edges will be there. Okay, ma? So on 12 edges, at the center of each edge, you will find one Na plus ion. Are you able to understand? And one more octahedral void where it is present. One octahedral void. Okay, ma? Exactly at center of cube. At center of cube. Are you able to understand, ma? Is it clear? So this is the arrangement of octahedral voids. Octahedral voids, they will be present on edges, center of the edges. And one octahedral void will be present exactly at the center of this cubical unit cell also. Are you able to understand? So therefore, how many Na plus ions they are touching this cubic unit cell? Totally how many Na plus ions are touching? Can you say? Student, how many edges? 12 edges. So 12 Na plus. Are you able to understand, ma? I am not discussing by mass. By mass gurinchi maatladam ledhu. Total number of ions I am talking. Clear? Total number of ions are 12 because 12 edges. And at the center also one Na plus will be present. So totally how many Na plus? 13. So totally 13 Na plus will be in contact. Will be in contact with what? Will be in contact with cubic unit cell. Okay, ma? So this is the arrangement of Na plus. Are you able to understand? So therefore, how many atoms are present by mass, ma? How many sodium ions are present by mass, can you say? If you calculate by mass, according to number, 13 plus 12 plus 1, 13. Mass number prakaram this could 13 contact lo untayi. Clear, no? So if I contact by mass how many atoms will be in contact? Okay. So how many edges are there? 12 edges. What is the contribution of an edge? 1 by 4. Contribution by edge anta? 4. If atom is present at corner? 1 by 8. If atom is present at the center of face? 1 by 2. At edge? 1 by 4. Already we have studied, no? Clear, no? So therefore, number of atoms by mass. Number of atoms by mass is how much? It is, contribution is 1 by 4 multiplied by 12. because 12 edges will be there, and on each edge there will be one Na plus ion. Clear, no? And at the center also there is an ion, no? And what is the contribution when atom is present at the center? 100% contribution. Clear, no? So plus 1 into 1. So total how much, ma? So 3 plus 4, 4 atoms of Na plus. Are you able to understand? So in cubic unit cell, by mass, how many sodium atoms will be present? 4 sodium atoms will be present. Are you able to understand, ma, how we are calculating? Similarly, let us study about the arrangement of Cl minus. Okay, ma? Arrangement of Cl minus. Cl minus anion. Okay, ma? So they are arranged in FCC manner, or you can call it as CCP unit cell also. Okay, ma? So Cl minus ions, where you can find Cl minus ions, they are present where, ma? They are present on in FCC manner. What is meant by FCC manner? Face centered cubic. Face centered cubic means, Chapan Twarga, each atom will be present at the center of face. How many faces? 6 faces. So 6 Cl minus ions. And Cl minus, they will be present at the corners also, no? Okay, ma? How many corners? 8 corners. So 8 atoms at corners, 6 atoms at center of face. 8 plus 6, so total 14. So 14 Cl minus ions will be in contact with 1 cubic unit cell. Are you able to understand? So write down that. So therefore unit cell means what? So each Cl minus at 8 corners. That's all, no? And each Cl minus at center of face. Okay, ma? So total how many faces, ma? 6 faces. So total how many atoms? Total how many atoms are in contact? 8 plus 6, 14 atoms are in contact. 14 atoms are in contact with what? Unit cell, cubic unit cell. Clear, no? And by mass, how many of them are present? How many atoms by mass? By mass, how many atoms? How can I calculate? So 8 are present at corners, no? What is the contribution of each corner? 1 by 8. How many atoms? 8 atoms. So 1 by into 8? 1. Similarly, face. What is the contribution of a face? 1 by 2. Face is 1 by 2. How many faces? 6 faces, so 6 atoms. 1 by 2 into 6, 3. So total 3 plus 1 is how much, ma? 4 Cl minus ions, they are present in 1 NaCl unit cell. Are you able to understand, ma? So therefore, in 1 unit cell, you can find 4 atoms of Na plus and 4 atoms of Cl minus. Understood, ma? So how many formula units will be present? 4 formula units will be present. 1 NaCl is called 1 formula unit. Are you able to understand, ma? 1 NaCl is called as 1 formula unit. So totally how many formula units, ma? So 4 formula units will be present in 1 unit cell. ఒక యూనిట్ సెల్ అన్నిటినీ కంప్రైజ్ చేసి ఉంటుంది. అండర్స్టూడ్, అమ్మా? దట్స్ ఇట్. సో మేక్ నోట్ అప్ టు హియర్. ఓకే, shall I rub this side, ma? Right now. Right, ma? So therefore, okay, ma? Therefore, number of formula units in 1 unit cell. How can I calculate? 4 Na plus 4 Cl minus, total will give 4 NaCl. Okay, ma? So 4 NaCl formula units, they are present in 1 unit cell by mass. This is not by number, ma. This is by mass. Mass veru, number veru kada. Number already we have calculated here. 13 Na plus and 14 Cl minus. But these are only numbers which are in contact with the unit cell. But I want by mass, no? By mass 4 NaCl and 4 Na plus and 4 Cl minus, they are in contact. అర్థమవుతుంది కదా? వెరీ సింపుల్ కాన్సెప్ట్ మా. Clear? So therefore, let us do one thing. Let us draw the structure of this NaCl crystal, so that we will do one thing. We will do, for remaining crystals are also there, no, CS, Cl, all these crystals are there. No? For these crystals also you will get same models. So I will do one thing. I will discuss all the possible models for NaCl. Then you apply the same models for other crystals also. Are you able to understand? Okay. See the structure of NaCl unit cell. First of all, we will identify Na plus ions. Okay. So here Na plus ions will be indicated by red color, and Cl minus ions will be represented by green color. Are you able to understand, ma? Now can you say what is the arrangement of Na plus, ma? Where Na plus will be present? On all octahedral voids. Understood, ma? So see here I have written. So all Na plus, they are arranged on octahedral voids. And what is the arrangement of octahedral voids, ma? Octahedral voids, they will be present where? They will be present at the center of each edge. Clear, no? And also one octahedral void will be present exactly at the center of the unit cell. Understood, ma? So therefore, so this is Na plus. Clear, ma? And here also there is one Na plus, and this is one Na plus. So totally how many edges, ma? 12 edges. So 12 Na plus will be present. Okay. Are completed, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, ma? And there will be one Na plus exactly at the center of this unit cell. So this is the arrangement of Na plus ions. Clear? Now what about Cl minus ions, ma? Where Cl minus ions will be present? Exactly at FCC structure. We have studied FCC structure, no? FCC means what? 8 atoms at corners and 6 atoms at the center of the face. That's all, no? So draw them. So at corners, so this is one Cl minus. Clear, ma? So this is another Cl minus, another Cl minus. So this is another Cl minus. Clear, no, ma? Another Cl minus, Cl minus, Cl minus, and here also one Cl minus. Okay. And exactly at the center of the face also, no? So therefore this is one face. So here there will be one atom. Clear, no, ma? And here there will be one atom. And here there will be one atom. Clear, no, ma? And here there will be one atom. And to this upper face, what is the center of upper face? Somewhere here. So here there will be one Cl minus. Here there will be one Na plus. And to the center of this face is somewhere here. So this is another Cl minus. So this is the arrangement of all Na plus and Cl minus ions. Are you able to understand, ma? Clear, no? Okay. So draw this diagram carefully, ma. Now the question is, arrangement of atoms we have understood, no? Now which atom is touching which atom? This is very important, no, ma? So unless you don't understand which atom is touching which atom, you can never understand what is the formation of this crystal. Are you able to understand? See, which atom is touching which atom, can you say? Already we have discussed, no? Each Na plus will be surrounded by 6 Cl minus. It means the nearest Cl atoms, all of them, they are surrounding one Na plus. Similarly, each Na plus will be surrounded by 6 Cl minus also. They may be in the same crystal, they may be in the same unit cell, they may be in the other unit cell also. That is a different point. Are you able to understand? So therefore, for example, if you see this is Cl minus, this is one Cl minus, no? So this is Cl minus, listen very carefully, listen. Okay, student. So if you take this is Cl minus, this Cl minus will be touching 1, 2, 3, 4, 5. 5 Na plus in the same unit cell. Vinandi. Are you able to understand? So questions will be given on this arrangement only, no, ma? Questions pure ga arrangement paine istaru. Okay? Arrangement artham gakapote evarni touch chestunnaro artham gakapote you can never solve the problems of NaCl crystal. Clear? So listen carefully. So here there is one Cl minus. No, where is this Cl minus? Ma? It is at the center of a face center lo undi, and it is surrounded by 1, 2, 3, 4 Na plus ions. And where these 4 Na plus ions are present? They are present on the same face. Understood, no? And here there is one Na plus. And where this Na plus is present? At the center of the cube. Na plus is present at the center of the cube. So totally how many atoms it is touching? 1, 2, 3, 4, 5. What about the sixth atom? Above this unit cell there will be one more unit cell, no? ఈ యూనిట్స్ పై ఇంకొక యూనిట్ సెల్ ఉంటుంది కదా. సో టు ద సెంటర్ ఆఫ్ దట్ యూనిట్ సెల్ దిస్ Cl minus will be touching. That's all. 6 Na plus are surrounded by 1 Cl minus is surrounded by 6 Na plus, like this. Are you able to understand what is happening? 5 Na plus they are present in the same unit cell. Okay, 1 Na plus is present at the center of the unit cell which is above this unit cell. దీని పైన ఇంకొక యూనిట్ సెల్ ఉంటుంది కదా, దాని మధ్యలో ఒక Na ప్లస్ ఉంటుంది కదా, అది కూడా ఈ Cl మైనస్ ని టచ్ చేస్తూ ఉంటుంది. ఓకే, సో ఈచ్ Cl మైనస్ is joined by 6 Na plus and 1 Na plus is surrounded by 6 Cl minus. Are you able to understand? And 2 Cl they can never be in contact. Okay ma, 2 Cl minus they can never be in contact. Similarly 2 Na plus also they cannot be in contact. అర్థమవుతున్నాయి కదా, దగ్గరగా ఉన్న ప్రతి ఒక్కటి టచ్ అవుతాయి. సిమిలర్ cations or similar anions they are never going to touch with each other. Are you able to understand? So make a note of that point. So therefore what we write, okay ma, for example I will write, let this one be given the name 1, 2, 3, 4, 5, 6. Clear number? So 1 is in contact with what? 2, 3, 4, 5, 6 and 7th Na plus at the center of another unit cell, above the present unit cell. Are you able to understand what is happening? Clear? So 1 is in contact with 2, 3, 4, 5, 6 and there is one 7th numbered Na plus, no? Where it is present? It is present above the unit cell in the second unit cell. Are you able to understand? So like this, if you take any cation or any anion, one cation is surrounded by 6 anions and one anion is surrounded by 6 cations. Clear? Similarly one more point is that, okay ma, no 2 Cl minus will touch each other. Okay, and similarly no 2 Na plus will touch each other. So just if you know this much amount of information, then I hope you can solve any kind of problem given on Na plus crystal, NaCl crystal. Are you able to understand? That's it, very simple. Okay, let's see this question ma. So edge length of Na plus unit cell, okay ma, is 200 picometer. Now what is meant by edge length ma? Edge length means what? This length. This is called one edge length, no? Are you able to understand ma? Represented by A. Okay, or you can call this is the edge length which is called as A. This is the edge length, this is also the edge length. Okay, so what is the edge length given? Edge length given is 200 picometers. Clear? So 200 into 10 power minus 12 meters. So radius of Cl minus ion is 60 picometer. Okay ma? So radius of R minus is how much ma? 60 picometer. Then calculate the radius of cation. It means we are supposed to find out radius of Na plus. That's what we are supposed to calculate. Clear? See ma, in edge lengths, what is the method of calculation? Make a note point of this one. Okay, hint is that take a line in which atoms are touching with each other. Atoms are touching with each other. Okay, ma? So in calculating distances, ma, this is the hint. Always take a line. In that line, all the atoms, they should be touching with each other. There should not be any gaps between the atoms. Arthamatunda? So take any such line. Which line shall I take? I can take this edge length only, no? Are you able to understand? At the middle, what is present? Na plus is present, no, ma? So this is Na plus. And what is this one? This is Cl minus. Now the question is, so this atom and this atom, are they in contact with each other or not? Leva? Na plus is in contact with Cl minus? Definitely it is in contact. And what about Na plus contact with another Cl minus? It is also in contact. Are you able to understand, ma? Because already we said, no, the nearest cation and anion, definitely they are in contact with each other. No two cations are touching, no two anions are also, they are not touching. Are you able to understand? So therefore, if I draw the diagram here, how can I draw the diagram, ma? So consider this is the edge length. Okay? So if this is the edge length, this is Na plus. Okay, ma? And what about Cl minus? So this is the Cl minus. So this is the Cl minus. So this is also one Cl minus. Okay, ma? And what about this one? This is Na plus. So definitely they are in contact with each other. Are you able to understand? Now see, what is this distance? What is this distance? This distance can be written as 2 times of R plus. Can I write? 2 times of R plus, no, ma? R plus means what? Cation, radius of cation, radius of sodium ion. This is diameter, no? Diameter means 2 times of R plus. Okay. Then what is this distance? What is this distance? It is 1 R minus, no? Radius of chlorine atom. Clear, no, ma? Then what about this distance? This distance is also R minus. Okay. And this total distance is nothing but edge length A, no? What is this total distance? Edge length A. And edge length A is already given, no, ma? How much? 200 picometers. So therefore I can say that R minus plus 2R plus and R minus, all of them if you add, 2R minus plus 2R plus, it is equal to A, and which is equal to 200 picometer. Can I write like this? Okay. If you add all of them, it is equal to 2R minus and 2R plus, which is equal to A, which is again equal to 200 picometer. Okay. In that one, the length of R minus is already given, no? Substitute that one. Okay, ma? So therefore 2 into 60 plus 2 into R plus is equal to 200. So 2R plus is how much, ma? 200 minus 120? 80. So therefore R plus will be how much? 40 picometer. Okay. So therefore is if the radius of Cl minus is 60, radius of Na plus is 40. That is our answer. So this problem we are able to solve only when we know arrangement of atoms, where atoms are present and which atom is touching which atom. That's it. Okay, ma? Inko problem is cheyandi. Okay, see, ma. So see this question. Okay, ma? So the edge length of NaCl unit cell is 200 picometers. Now then, first of all, let us see the first one. Distance between two opposite charges. Clear, na, ma? So distance means what, ma? Distance means shortest distance, ma. Distance ante edi padithe adi distance teesukodu. Distance means that shortest distance between the given values, the given anions or cations. Okay. So therefore, shortest distance between what? Shortest distance between two opposite charges. Okay. And definitely which will be the shortest distance? The atoms which are touching with each other. Antakana shortest inke undadu kada. The atoms which are touching with each other, definitely they will be the shortest. One atom cannot enter into another atom, no? Two concentric atoms are not possible, no? Atoms which are touching with each other, only that distance will be the shortest distance. Okay. So this Cl minus and Na plus, they are in contact with each other, no? So draw the diagram of this. So this is one, this is the arrangement, okay ma? So this is Cl minus and Na plus, clear, no? So what is this total distance, okay ma? So this total distance will be how much? This total distance will be 2r plus 2r minus. Already we have studied this one, no? 2r plus and 2r minus. Clear, no? And cation, opposite charges means cation and anion. So I wanted this distance. This distance will be how much? Exactly half of. So this distance will be how much? 2r plus 2r minus divided by 2. That much will be the distance. That's all, no? And this distance is also called as edge length, no ma? Ade distance name antam manamu edge length ani kuda antam. Clear? And how much is the edge length given? 200. So what we want? I want a by 2, and a by 2 is nothing but 2r plus 2r minus divided by 2. So 200 divided by 2 is how much? 100 picometers. So that is our answer for the first question. Is it clear? That's all very simple. Make a note. Question. So second question, what he is asking, second question is, okay ma, distance between two cations. It means that shortest distance between, cation means Na plus, no? Shortest distance between two Na plus, okay? Now see the arrangement of Na plus ma, okay? So here there is one Na plus, here also there is one Na plus, no? So what is the distance between both of them? A, edge length A only, no? Okay ma? So what is this length? This length is nothing but edge length only, no ma? A. So distance between this one and this one is A. Definitely not the shortest distance. Clear, no ma? Similarly, you take a distance between this one and this one, okay? Or this is one edge length, this is another edge length, no? So this distance is A by 2, this distance is also A by 2. This is A by 2 only, no ma? This is also A by 2. Understood? Or you take these two. Okay, what is this length? A by 2. This length is also A by 2. I want this distance. That distance will be the shortest distance. Are you able to understand? See, this Na plus and this Na plus, they are present on the edges which are present on the same face. Are you able to understand? See, this Na plus, it is present on the upper face, no? This Na plus is also present on upper face. So distance between these two will be the shortest distance. Are you able to understand? So how much will be that distance? Let us call that distance as x. Okay. So therefore x value, how can I calculate? X value is equal to square root of a by 2 whole square plus a by 2 whole square. Pythagoras theorem. Right angle triangle is formed, no? Right angle triangle then apply. So therefore it is equals to square root of a square by 4 plus a square by 4. So 2a square by 4 root. Yes, coach. Clear, ma? So square root of a square by 2. So therefore a by root 2. What is a value given? A value is nothing but 200. So 200 divided by root 2. So 200 divided by 1.414. That is the answer. Clear, no? So definitely it is not 20. 20 అయితే కాదు పొరపాటు కూడా. ఏది చూసేది? ఈ ఆన్సర్ ప్రకారం చెప్పండి. మ్యాథమెటిక్స్ ఎలా చేసినా ఒకే విధంగానే రావాలి. Now see, let us see. So I too don't know what is the answer. I think for that also I think it will be a by root 2. Let us see. Okay, ma? So third one, distance between two anions. Anions means Cl minus. Now let us search for Cl minus, ma? Shortest distance. So definitely this distance will be the shortest distance. Okay. No other distance is as short as these two Cl minus, no? So this is one Cl minus present at one corner. This is one Cl minus present at the center of the face. Definitely that distance will be the shortest distance. Are you able to understand? And what is this distance? This distance is this one. This is a face diagonal, no? What is the length of face diagonal? A by root 2 na. Root 2a. Length of face diagonal is how much? root 2a. Okay, so I'm writing here. So length of face diagonal is how much? It is root 2 into a. Okay, but this is half of the face diagonal, no? This distance is half of the face diagonal. Okay, let us calculate, consider this distance as x dash. So x dash will be how much? Root 2a divided by 2. So it is a by root. We got same answers. Okay, ma? Here also a by root 2, here also a by root 2. So therefore this distance is also 200 divided by 1.414. That is our answer. Is it clear, ma? Same also. Question is, how many unit cells are present in 5.85 grams of NaCl? Okay, ma? So therefore, how much mass of NaCl is taken, ma? 5.85 grams of NaCl is taken. Are you able to understand? So what is the molecular weight of NaCl, ma? Molecular weight of NaCl is how much? It is 58.5 grams. Are you able to understand? Molecular weight of NaCl is approximately 58.5 grams. Okay, or you can call it as AMU also. If you say AMU, it is related to one formula unit, and if you say grams, it is related to 1 mole. So 1 mole of NaCl will have this much mass of NaCl. Okay, ma? So this is also called molar mass. Okay, so how can I calculate number of moles in given crystal, ma? In given sample? Number of moles formula? So total given mass divided by molecular mass. Okay, ma? This is the formula, no? Total mass, if you divide it by molar mass, then you will get how many moles are present in that particular sample. Number of moles kanukodaniki chala methods unnai kada. This is one method. One more method is you can write total number of atoms, molecules or ions divided by Avogadro number of molecules. Similarly, in gas you can write total volume divided by volume of 1 mole. That is 22.4 liters. Any method you can use. Are you able to understand? So what is the amount of mass given? Mass given is how much, ma? 5.85. And what is the molar mass? Molar mass is 58.5. So total how many? 0.1 mole of NaCl is given. In the given sample, how many moles are present? 0.1 moles are present. Clear? Therefore, number of NaCl units will be how much, ma? I am not talking about unit cell. I am talking about NaCl formula units. Okay, ma? So how many NaCl formula units will be present, ma? 1 mole. How many moles? 0.1. Each mole will have how many atoms or how many molecules? 1 Avogadro number. That's all, no? Clear, no? 1 mole will have 1 Avogadro number of NaCl crystals, NaCl formulas. But how many moles are there? 0.1. So therefore 0.1 into Na. And what is Na? 6.624 into 10 power. How many, ma? Sorry. I am confusing with Planck's constant. Okay, ma? 6.023 into 10 power 23. Na plus formula units are present in 0.1 mole. Okay, ma? But he is not asking how many NaCl formula units. No, what he is asking? He is asking how many unit cells will be present. Unit cells, how can I calculate? In 1 unit cell of NaCl, how many Na plus are present? How many NaCl are present, ma? 4 are present, no? By mass. By mass, how many NaCl are present? 4. Already we have calculated, no? 4 Na plus 4 Cl minus. So totally 4 Na plus formula units are present in 1 unit cell. Therefore, in terms of unit cell, how many unit cells are present? 0.1 into Na divided by 4. So do this calculation. That is my required answer. అర్థమవుతుందా ఎలా చేస్తున్నామో? Number of moles given by this formula. Number of molecules given by 0.1 into Na. So this is the total number of NaCl formula units. But one unit cell will have how many unit cells? How many Na plus formula units? 4. So total number of molecules divided by 4. That's all. So these many unit cells will be present. That is our answer. Whatever may be the answer. Understood, Nama? That's all. So some more problems we will do tomorrow, and tomorrow we will end this class of solid state. Okay, ma? So see, ma, this is the next question in NaCl crystal. See how many ions are present in 1 meter body diagonal in NaCl crystal. A is given as 200 picometers. A means what? Edge length. Edge length is given as 200 picometer. Then in 1 meter, what you call body diagonal. Okay, ma? There will be body diagonal to be a cubic crystal, no? And what is the length of the body diagonal he is taking? 1 meter. So in 1 meter body diagonal, totally how many ions can be present in this NaCl crystal? Clear? Come on. Okay. Question is in body diagonal, okay, ma? How many ions can be present? Ions means what? Both positive ions as well as negative ions. So totally how many Na plus and Cl minus can be present on the body diagonal? Okay. Now first of all, let us identify the body diagonal. Ma, can you say, Sima? This point, it is out of the board, no? This point, which point shall I take out of board? Okay. So I will take this point to be present out of the board. Then which point is present inside the board? Let us take this is the outer surface, and let us take this one is the inner surface. Are you able to understand, ma? So this is inner surface, this is outer surface. I will do one thing, ma. I will draw this line. Okay. So this line also, it will become body diagonal, no, ma? Okay. This Cl minus ion, it is present inside the board, behind the crystal. Okay. Then what about this Cl minus ion? It is present out of the board. So definitely that will become body diagonal only, no? What is meant by body diagonal already we have studied, no, ma? Clear, no? So this is the Cl minus ion which is present behind the board. Board venakal undedi. And what about this Cl minus? It is present on the front side of the front face of the cube. Are you able to understand? Now can you say on this body diagonal how many Cl minus and how many Na plus they are present? Can you say? How many? You should not be confused by the diagram. You should be very clear about the positioning of Na plus and Cl minus. Are you able to understand, ma? Na plus ekkada untayi cheppandi, where Na plus are present?
Edges and the center of point.
Come on, ma.
Edges and center of point.
So Na plus, they are present at the edges, no, ma? All these red color dots which you are seeing, they are Na plus. Are you able to understand? And at the edges, how many edges are there? 12 edges are there. And there is one Na plus exactly at the center also. So this is one NaCl. Are you able to understand? Then where Cl minus they are present? Cl minus they are present at the corners, 8 corners. And they are present at the center of the faces also. Are you able to understand? Okay, now see. Now this body diagonal, it is touching this Cl minus, no? Because it is present at the corner. Arthamavutundi kada? Same body diagonal, it will touch this Cl minus also, no? Because it is also present at the corner. Are you able to understand? Now this body diagonal, can it touch this Na plus? Na plus no touch avutunda cheyada?
Yes, sir.
Why? Why it will touch? Because Na plus is exactly at the center, no, ma? Where Na plus is present? Exactly at the center. So body diagonal must touch Na plus. What about this Cl minus?
Those are face side of the
Touch avutunda avada? This Cl minus cannot be touched. Are you able to understand, ma? Okay. So this Cl minus will touch this body diagonal. This Cl minus also will touch. But this Cl minus, it is present at the center of the face. It is not at the middle of this unit cell. Madhyalo ledhu kada adi. It is present on the face. Face paina undadi. So therefore this Cl minus cannot be touched. What about this Cl minus? It is also present behind the face of the this unit cell. So this also cannot be touched, and this will be touched. Okay. So therefore on this body diagonal, how many ions are present totally? 3 ions are present, no? Okay, so let us draw this diagram. Next point is that, so first of all I will make that point. So on body diagonal, okay ma, how many ions are present? 3 ions are present. What are the 3 ions which are present ma? 2 Cl minus ions, 1 Na plus ion, it is present on the body diagonal. Artham avutundi kada? Now the question is, this Cl minus, this Na plus and this Cl minus, are they touching with each other or not? Touch avutunnaya leda? Cl minus, Na plus, Cl minus, are they touching with each other or not? Definitely they will be touching. They are negative opposite ions. No, avi a type of ions? Opposite ion. Each positive ion is surrounded by how many negative ions? 6 negative ions. 6 negative ions. Okay ma? So definitely this is Cl minus, this Na plus and this is Cl minus also, they will be touching with each other. So what is the next point I can write? All 3 ions are touching with each other. Okay. Yesterday only I said no, oppositely charged ions definitely they are touching. Similarly charged ions, they are not touching with each other. One Na plus is not contact with another Na plus. One Cl minus is not in contact with another Cl minus. But Cl minus Na plus, same type of opposite charges, no? So they will touch with each other. And Na plus and Cl minus, they are also opposite ions, no? Definitely they will touch with each other. Okay. So therefore if I draw the diagram, how can I draw the diagram? This is how I can draw the diagram. Clear ma? Okay. At the middle what is present? At the middle Na plus is present. Okay. What is this one? This is the body diagonal. Body diagonal. So Sima, to solve this type of problems, already I said, you know, where atoms are present and which atom is touching which atom. It is all important. Only 2 points. Where is the positioning of atom? First point. Which atom is touching which atom? Just if you remember these two, you can do any kind of problem. Are you able to understand? So then what about the Cl minus? So this Cl minus I am drawing. So this is the Cl minus and there is one more Cl minus. Are you able to understand? So therefore on this body diagonal 3 ions are present and all the 3 ions they are touching with each other. Are you able to understand? Okay. Now see ma, this is the arrangement, no? Vinandi chala careful, listen very careful. This is the arrangement, no? Now can you say, and what is this length? This length I can call it as A also, no ma? Ee length nenemantano? This length is also called as A root 3. Do you remember? What is the length of body diagonal? Edge length if it is A, okay ma? Edge length if it is A, face diagonal is A root 2. Body diagonal? A root 3. Clear, no? So therefore what is the length of this body diagonal? Length of this body diagonal is A root 3. This is the length of the body diagonal which is equals to A root 3. Are you able to understand ma? Okay. Now on this body diagonal, diametrically how many ions can be placed? Chappandi. On this body diagonal, diametrically how many atoms, how many ions can be placed? Any ions ni nenu place cheyochu? Diametrically. Only 2 only. How can you say? Actually 3 are present, no? But diameter wise only 2 atoms can be placed. How? See ma, this Cl minus only radius is present, no? And here also in Cl minus only radius is present. Radius plus radius, diameter. Okay. So therefore same body diagonal if I draw here, it is equivalent to that only 2 atoms can be placed. Can I draw like this? Understood, no ma? Actually on this body diagonal 3 ions are present. But diametric wise I can place only 2 atoms. Artham avutundi kada? Clear, no ma? So make a note of that point also. Diametrically only 2 atoms can be placed. Is it correct, ma? Okay. Therefore on A root 3 2 ions can be placed. Okay ma? On A root 3, what is meant by A root 3? Total length of the body diagonal. On total length of the body diagonal, how many ions can be placed? Only 2 ions can be placed. Okay. Then If I want to place only one ion, then what is the length of that length? Divided by 2. So therefore, on a root 3 by 2, a root 3 by 2, how many ions can be placed? Only one ion. So one ion can be placed. Are you able to understand, ma? So therefore, on this much of length, I can place only one ion. Are you able to understand? Now what is the total length of the body diagonal he gave? 1 meter. Total length of the body diagonal he gave is 1 meter. On 1 meter, how many a root 3 by 2s are present? That many ions can be placed, you know? Arthamatunda? What is the total length of body diagonal he gave? 1 meter. On 1 meter, how many a root 3 by 2s are present? How can I calculate? Okay, ma? So 1 meter divided by a root 3 by 2, it will give what? Can you say? ఒక మీటర్ని ఈ వాల్యూతో డివైడ్ చేస్తే ఏమొస్తుంది? In that 1 meter, how many a root 3 by 2s are present? That will be what I am getting to. Okay, ma? And what is meant by a root 3 by 2? Length of one ion. So 1 meter by a root 3 by 2, what I will get? The number of ions which can be placed on the body diagonal. Ante kada? Are you able to understand, ma? So this will give what? This will give number of ions that can be placed. On 1 meter body diagonal. 1 meter body diagonal. Are you able to understand, ma? That's all very simple. Okay. What is the length of, what is the radius of each ion, ma? Sorry, what is the diameter of each ion? A root 3 by 2. So these ions I should place on how much length? 1 meter length. So just divide 1 divided by the diameter of each ion, then you will get a number of ions which can be placed. That's all, no? And A value is already given, 200 picometer. Substitute. Therefore, number of ions which can be placed is 1 divided by a root 3 by 2. This I can write it as 2 divided by a root 3. Okay, ma? This can again be written as 2 divided by a value is how much? 200 picometer. Picometer means 12 power minus 12 multiplied by root 3. So therefore, 2 into 10 power 12 divided by 200 into root 3. So these many number of ions I can place on this body diagonal of length how much? Of length 1 meter. అర్థమైందా ఎలా చేసాము? Any doubts in the calculation? Is it clear? Okay. See, first of all, positioning of Na plus and Cl minus is very important. Positioning gurtundali. Are you able to understand? Next, we should see which atoms are touching with each other. Definitely on this body diagonal, all the atoms they are touching with each other because they are oppositely charged ions. Definitely they will touch with each other. Okay. And this is the total length. Actually, 3 atoms are touching. 3 ions are touching. But diametric wise only 2 ions can be touched. Okay. So on a root 3, which is called length of the body diagonal, 2 ions only can be placed. And divided by half only 1 ion can be placed. But how much length I have to consider? 1 meter. So divide 1 meter divided by diameter of each ion, you will get number of ions which can be placed. That's all. Fine? Very simple. Will make you understand this question. So see here. So find out the formula of NaCl crystal in following given conditions. In first conditions, all ions removed from body diagonal. Okay, ma? I am removing atoms or ions only from body diagonal only. It means I will draw one body diagonal and whatever atoms are touching this body diagonal, remove all the ions. Clear, nama? Second condition is you place a plane along the body diagonal. Plane means we know, nama, which has length and breadth is called as a plane. Thickness will not be there. So on the body diagonal perpendicular to the cube, place a body diagonal and whatever atoms are touching the body diagonal, you remove all the atoms. Then what is the formula of NaCl crystal? Is it clear? So I will do the first one. Second one you try to do, ma. See the first one. First one is all ions removed along. Ions removed. The background music and the ions removed along body diagonal. Clear, nama? See. So this is the body diagonal lemma which we have drawn in the last question. This is the body diagonal. So how many ions are touching? This Cl minus ion is in contact, no? The ion which is in the middle, Na plus, this is also in contact. And the ion which is present at the, this Cl minus also, which is at one corner, that is also touching the body diagonal. So 3 ions are touching. Okay. First of all, let us study about Na plus. Okay, ma? So, how many Na plus are present in this crystal by mass? Yesterday we calculated, no? How many Na plus are present in this crystal by mass? Mass prakaram ennu unnai? 4 are there, no? Okay, ma? See here. So, this body diagonal is touching only one Na plus, no? It is touching only one Na plus. Okay? And how many Na plus were present by mass? 4 Na plus were present, no? 4 Na plus will be there by mass in one unit cell. Already we have studied this one, no? Now from 4 Na plus, I have to remove one atom which is touching, no? Body diagonal is touching only one atom. And can you say what is the contribution of this atom? 100%. Why it is 100%? Ma? Because it is present at the center, no? So total atom is present only in that unit cell only. So contribution is 100%. Clear, no? So therefore, now available atoms are how many? Available atoms are how many, ma? After removing? It is 4 minus 1 is equal to only 3 Na plus are present. Are you able to understand? Okay. Now let us study about Cl minus. Okay. So previously how many Cl minus were present by mass? 4. 4 Cl minus were present by mass. That's all, no? Now body diagonal is touching how many Cl minus? 2 Cl minus. This one Cl minus and this is another Cl minus. But where this Cl minus is present? Corner. What is the contribution of corner? 1 by 8. So therefore how can I do the calculation? 4 minus of 2 are there, no? So 2 into 1 by 8. This is how I have to do, no? There are 2 atoms, so I am multiplying by 2. Contribution is 1 by 8, so 2 into 1 by 8. అర్థమవుతుంది కదా? Okay. So therefore 4 minus 1 by 4. How much? 15 by 4. Okay. So by mass NaCl are present 3. By mass Cl minus they are present 15 by 4. So take the ratio. Okay. Therefore Na is to Cl is equals to how much? 3 is to 15 by 4. Okay. So 12 is to 15. 12 is to 15 divisible by 3, no? 4 is to 5. So this is the ratio of Na plus and Cl minus. Now how can you construct the formula? Na for Cl5. That's all. This is my answer. Okay, ma? So this will be the formula of this crystal if ions present on the body diagonal, if they are removed. Okay. Now second one, can you do? When ions are removed along the plane, along the body diagonal, you place a plane like this. And all the atoms which are touching the plane, you must remove them. Clear? Try change. So next question is ions removed along the body diagonal. Sima, body diagonal means what? For example, this one, Sima. Where is this Cl minus ion, ma? This Cl minus ion, it is present out of the board. Clear, no? This Cl minus is present inside the board. So diagonal drawn like this. Clear, no? From here to here, this becomes the body diagonal. Are you able to understand? And through this body diagonal, you have to pass a plane. Then that plane will touch these atoms. Here you are seeing this red color border, no? Here you are seeing this red color border, no? This border will be the plane which we have drawn passing through the body diagonal. Are you able to understand? Cube ఎవరి దగ్గర ఉండాలి కదా, తెచ్చినారా? తెలియదు కదా? Okay. So exactly passing through the middle of this ఉందామా? తీసుకుంటాను ఉంటాయి. Are you able to understand what is happening? Okay. So this is the plane which is passing exactly through the body diagonal, and this plane, it will divide the cube into 2 equal halves. ఈ ప్లేను ఆ క్యూబ్ని ఎలా కట్ చేస్తుందో చెప్పండి. It will divide into 2 equal halves. Are you able to understand? And whatever ions they are touching this plane of this body diagonal, they should be removed. So Seema, so this is the cube, no? Cube. So how I have to place the body diagonal? I have to place the body diagonal like this. Okay? Then it is passing through to this volume of the cube. Okay? It means this plane, it cuts this body diagonal into this half and this half. That is the plane of the body diagonal which we have drawn. Are you able to understand? So body diagonal ekkadi nunchi pass avutundi? It passes like this. It passes like this. Clear number? And it will touch one end. Okay? And on the other side, it passes like this. Clear? And here also it will touch this edge. So this is the construction of the body diagonal. Artham avutundi kada? Are you able to understand? So plane should exactly pass through the center of this cube. Diagonally it should pass, so that cube is divided into exactly 2 equal halves. Are you able to understand? Sima, without any calculation also, can't we say the answer? Calculation em lekunda calculation cheppalema. Body diagonal is dividing the cube into 2 equal halves, nama, and 2 equal halves, they are symmetrical to each other, no? Are you able to understand? It means all the symmetrical atoms are removed. So therefore formula does not change, it remains to be NaCl only. It remains to be NaCl only. So Na1Cl1 only will be the final answer. By common sense we can say any calculation, but unfortunately we don't have any calculation, so we will do the calculation. Common sense anedi manaku jeevitanlo ledhu kada, so we will do the problem. Okay? So see. So what is the answer we got? 1:1. So NaCl will be again the formula. Okay? And that we have to prove by our calculations. So Seema. So first of all I will calculate with Na plus. Okay ma? Actually how many atoms are present by mass? Jayanti akko edo lokamlo unnavu, one lokamiki ravala. So actually 4 Na plus by mass. Okay ma? Now can you say this body diagonal is touching how many Na plus? Body diagonal is touching how many Na plus? 2. What are they? This one. This body diagonal is passing through this edge, you know. And next check this one. Okay? And same body diagonal is touching the middle one also, no? మధ్యలోంచి పాస్ అవ్వాలి కదా అది. At the middle of NaCl crystal what is present? Na plus is present. So therefore body diagonal is touching 3 Na plus atoms. Okay? Now see. So 4 minus, okay ma? So what is the contribution of these 2 atoms ma? 1/4. Why 1/4? Because they are present on the edges. Because they are present on the edges. So therefore I will write 4 minus 2 into 1/4. Or I can write 1/4 of 2 atoms. Okay? Minus, now what about the atom which is present at the center? Its contribution is 100%. 1. Clear, no? So therefore 4 minus 1/2 minus 1. Clear, no? So take LCM 2. So 8 minus 1 minus 2. So total how much ma? So 5/2, no? 5/2. Okay ma? So this is the number of NaCl atoms present by mass after removing all the ions which are touching the body diagonal. Understood, no? So ఏవేవి టచ్ అవుతున్నాయి చూడండి. This one is touching, this one is touching, and this one is touching. So we are removing 3 according to their contributions. Clear? Now see. Now we will calculate Cl minus. Okay? So actually how many Cl minus are present by mass? 4 Cl minus are present by mass. Okay ma? Now see how many ions is being touched by this body diagonal. Enni touch avutunayi cheppandi? At the corners how many are there? 1, 2, 3, 4. 4 of them they are present at the corners. Okay? And what is the contribution of a corner? 1/8. So 1/8 into 4. Clear, no? Because 4 atoms are present at 4 corners. Are you able to understand ma? So this one, this one, this one, and this one. 4. Now still any other? Here also there is one Cl minus, no? One phase. Here also there is another Cl minus or second phase. Okay? And what is the phase contribution? 1/2. How many atoms? 2 atoms. So do the calculation. So 4 minus 1/2 minus 1. Okay ma? So therefore LCM is again 2. Okay? So 8 minus 1 minus 2. So how much ma? 5/2. Again I got the same answer. So 5 by 2 is to 5 by 2. So therefore what is the formula? 1:1 ratio. By symmetry also can't I say the answer? This body diagonal, it is symmetrically cutting the unit cell. No? Symmetrically cut చేస్తుంది కదా. So definitely equal number of NaCl and equal number of Cl minus should get cancelled with each other. Okay. So therefore the formula unit is how much? Formula unit is NaCl. That's it. Because they are present in the ratio of 1:1. అర్థమవుతుందమ్మా ఎలా చేస్తున్నామా? So same type of calculations you can do for the next 4 crystals also which we are going to study. మనం అన్ని Na ప్లస్లో చేస్తున్నాం కదా in NaCl. Same calculations you can do for remaining crystals also. Understand? Just you should know only 2 things very carefully you should remember. What is the first point? Where atoms are present in the unit cell. Unit cell లో atoms ఎక్కడ ఉన్నాయి. And next point is which atom is touching which atom. That's all. Then everything will be very easy. Fine. That's it. Crystals we will study at the same time to save time. Okay. So see. So first one we are studying about ZnS crystal. Okay ma. So Zn2 plus and we will study S2 minus. So these ions, the ions which are present in ZnS crystal. Zn zinc 2 plus sulfur 2 minus. Are you able to understand ma? So let us see what is the arrangement of Zn2 plus ma. So presented half of tetrahedral voids. Okay ma? Where Zn2 plus they are present ma? They are present at half of tetrahedral voids. And what is the arrangement of tetrahedral voids ma? Do you remember? ఓ ఏం మాట్లాడుతున్నారు సార్ ఎప్పుడో 3 రోజుల కిందట జరిగింది ఇంకేం గుర్తుంటారు మాకు చిచ్చే అరేంజ్మెంట్ ఆఫ్ టెట్రాహెడ్రల్ వాయిడ్స్ వేర్ టెట్రాహెడ్రల్ వాయిడ్స్ విల్ బి ప్రెసెంట్ ఇన్ ద యూనిట్ సెల్లో టెట్రాహెడ్రల్ వాయిడ్స్ ఎక్కడ ఉంటాయి దే ఆర్ ప్రెసెంట్ ఆన్ ద బాడీ డయాగ్నల్ at a distance of d/4 from the corner. Already we have studied, no? Okay ma? Where the tetrahedral voids are present, the tetrahedral voids they are present at the body, on the body diagonal. And on each body diagonal, 2 tetrahedral voids will be present. Total how many body diagonals? Body diagonals ennu untayi? 4. 4 2s are 8 tetrahedral voids will be present. Okay ma? And these Zn plus only half of the tetrahedral voids will be filled by zinc ion. Are you able to understand ma? So therefore, okay ma? So 4 tetrahedral voids will be filled. It will fill how many tetrahedral voids ma? 4 tetrahedral voids it will fill. Okay? And what is the contribution of each tetrahedral void? Contribution anta adi kuda kavali kada. What is the contribution of each tetrahedral void? 100%. Because the tetrahedral voids where they are present? On the body diagonal. And body diagonals they are present inside the cube, no? Body diagonals paina untaya lopala untaya? Lopala unta mari atoms kuda lopale undali kada. So therefore contribution is how much? Contribution is how much ma? It is 100%. Are you able to understand? So therefore how many Zn plus ions are present? 4 Zn plus ions will be present. Are you able to understand? Clear nama? Next let us write the discussion about S2 minus. Okay ma? Where they are present? They are present at FCC. Okay? FCC, face centered cubic unit cell. What is meant by FCC? Already we have studied, no? All the atoms they are present at the corners and there are 6 atoms present at the center of 6 faces. So what is the contribution of FCC? So if they are present at FCC, how many atoms they are present by mass? 4 already we have studied, no? Calculation I am not doing. Okay ma? Therefore 4s2 minus are present by mass. Okay ma? In calculation malli cheyalsina avasaram ledhu kada, you do the calculations. Are you able to understand? 4 sulfur ions they are present in the unit cell. Okay ma? So therefore how many zinc ions? 4. How many sulfur ions? 4. So how many formula units will be there? 4 formula units. That's all, no? So 4 Zn2 plus and 4s2 minus, they will give rise to 4 Zns. Clear ma? So therefore formula units, number of formula units will be how much? that is represented by 4, and Z value is equal to how much more? Z value is 4. Are you able to understand? Next we will study about coordination number. Coordination number. Okay, what is meant by coordination number? Already we have studied, Nama. How many atoms are surrounded which are present at the nearest distance, that is called as coordination number. Okay, ma? So first of all I will study about Zn2 plus. Zn2 plus. Okay, so Zn2 plus, where they are present? At tetrahedral void. If atoms are present at tetrahedral void, then their coordination number will be how much? It will be equal to 4. Okay, so if you want to make a note of that point. Okay, ma? If atoms are at tetrahedral voids, then coordination number will be how much? 4. Coordination number ఎంత ఉంటుంది? 4. So zinc, they are present on tetrahedral voids only, no? So coordination number will be 4. Understood, no? Then we study about S2 minus. S2 minus. Where S2 minus they are present, ma? S2 minus they are present where? They are present on FCC. It means atoms, they are present at the corners, no? Atoms, they are present at corners. If atoms are present at corners, coordination number is 8. Okay, ma? Corners lo atoms unte coordination number ఎంత ఉంటుంది? 8 ఉంటుంది. But for sulfur it is 4 only. Why? Sulfur కి మాత్రం 4. Why? Because each sulfur is not surrounded by 8 zinc. It is surrounded only by 4 zinc. Why? Because they are not present totally on all the tetrahedral voids, no ma? Zinc is present only at half of the tetrahedral voids. అంటే సగం atoms సరౌండ్ అయి ఉంటాయి కదా. సో కోఆర్డినేషన్ నెంబర్ విల్ బి హౌ మచ్? యాక్చువల్ ఇట్ ఈస్ 8/2, విచ్ ఈస్ ఈక్వల్ టు 4. Understood, no? So make a note of that point. What is the note point here? I have to write note point is that if atoms are at corners, okay ma, then coordination number will be how much? Coordination number will be 8. Okay, but only half of zinc atoms or zinc ions are present. Okay, therefore coordination number will be how much? 8/2, which is equal to 4. This is the coordination number of S2 minus. అర్థమవుతుందా ఎలా చదువుతా ఉన్నామా? Clear ma? So all the important points I am writing on the board itself, ma. So just if you look at the notes, I hope you should be able to understand everything. Clear? Next. So what is the second crystal? Second crystal is CsCl crystal. Okay ma? So cesium chloride crystal. CsCl crystal. So write down. So Cs plus, it is present where? It is present at center of cube. Okay ma? Cl minus, it will form PCC, primitive cubic unit cell. అర్థమవుతుంది కదా? And this where are the positions that you have to by heart. Shall I draw the diagram? అలా డయాగ్రామ్ వెళ్ళాలంటే దానికి 2 నిమిషాలు వేద్దాం. క్లియర్ మా? So where Cs is present, ma? Cesium is present only at the center. Only one atom is present at the center. And where Cl minus is present? Cl is minus is present at the primitive cubic unit cell. What is meant by PCC? PCC ante? Atoms are present only at the corners. That's all. How many corners are there? 8 corners. So these are 8 Cl minus ions. That's all. That's all. Are you able to understand, ma? So 8 corners, 8 at 8 Cl minus, they are present. Okay. Now can you say for Cs plus, what is the contribution of how many Cs plus will be there in this unit cell, ma? Only one, because only one atom is present at the center, and its contribution will be how much? 100%, because it is exactly at the center, no? So therefore 1 Cs plus in this unit cell by mass. In this unit cell by mass. Clear? Now what about Cl minus? Cl minus, where atoms are present? Corners. How many corners? 8 corners. What is the contribution of each corner? 1/8. So how many total? 1/8 into 8 is 1. So therefore 1 Cl minus by mass. Clear nama? So therefore what is the formula unit? Formula unit is how much ma? Clear ma? 1 CS plus 1 CL minus give rise to CS CL. One formula unit. So therefore Z value is how much? Z value is 1. Are you able to understand? Next we will study about coordination number. Okay ma? Coordination number. So first of all we will study about coordination number of CS plus. Can you say how much? చూస్తానే చెప్పొచ్చు కదయ్యా. CS is surrounded by how many CL? 8 CL. 8 is the coordination number. ఏమి టైప్ అయినారు మీరు లాస్ట్కి? 1 + 1 ఎంత చెప్పండి? అబ్బా పోన్లేండి ఇదేనా చెప్పినారు. 1 CL is present at the middle surrounded by 8 CL, no? CS is present, 8 they are surrounded, so coordination number is 8. Clear, no? Then what about coordination number of CL minus ma? CL minus. Where CL minus is present? Corners. Corners lo unte coordination number is how much? 8. Already we have discussed, no? If atoms are at corners, then coordination number is how much? 8. రాయండి మరి, ఏదో లోకంలో ఉంటారు మీరు. Clear ma? So this is about the crystal called as CSCl crystal. Understood nama? Next let us write the third crystal, which is called as fluoride crystal. Okay ma? Third crystal is which crystal? Fluoride crystal. And what is meant by fluoride crystal ma? CaF2. This is called as chloride crystal. Are you able to understand? So therefore Ca2 plus, it will be present on FCC. Clear nama? F minus, it is present where? It is present on tetrahedral voids. So this is the arrangement, and this arrangement you have to by heart. That's it. Are you able to understand? Now see. క్లాస్ చెప్పేటప్పుడు ఎవరో మాట్లాడుతూ ఉన్నారు. సో సీమా, సో Ca2 plus it is present on FCC and F minus it is present on all tetrahedral voids. Okay. If atoms are in FCC, then how many atoms are present by mass? చెప్పండి. 4 Ca2 plus by mass. Are you able to understand ma? And if tetrahedral voids, if atoms they are present on tetrahedral voids, how many tetrahedral voids are there? 8 tetrahedral voids are there. Where tetrahedral voids will be present? On body diagonals. How many body diagonals? 4. 4 2s are 8 tetrahedral voids are present. So 8 F minus are present. Okay ma? By mass. By mass 8 fluoride ions they are present. Clear na ma? So therefore 4 Ca2 plus 8 F minus will give what? It will give 4 CaF2. This is the formula which I will get. 4 CaF2. Okay ma? So therefore number of unit cells, number of formula units is how much? Suppandi, number of formula units are 4. Z value is equal to 4. Understood, no? Next we write coordination number. Okay ma? So coordination number of Ca2 plus will be how much? Enta suppandi. It is present where? FCC. FCC means atoms they are present at corners, no? Corners means what is the coordination number? 8. Clear nama? Then which one? Fluoride. Clear, no? Where they are present? Tetrahedral voids. If atoms are present at tetrahedral voids, then what is the coordination number? 4. So this is the coordination number. Clear ma? So what is meant by 8 and what is meant by 4? Ca2 plus is surrounded by 8 fluorine ions, and each fluorine ion is surrounded by 4 Ca2 plus ions. That is the meaning of this. Okay? దీని చుట్టూ 8 ఉంటాయి ఫ్లోరిన్స్. That is why its coordination number is 8. దీని చుట్టూ Ca2 plus ఎన్ని ఉంటాయి? 4 ఉంటాయి. That's why its coordination number is 4. That's all. Are you able to understand ma? Last one. So last crystal is called anti-fluoride crystal. Okay ma? So anti-fluoride crystal. And what is its, for example, we are taking Na2O. Why it is called anti-fluoride crystal ma? ఇక్కడ ఫ్లోరిన్ ఉంది కాబట్టి ఫ్లోరైడ్ క్రిస్టల్. ఇక్కడే ఉంది ఫ్లోరిన్ ఉంది అక్కడ లేదు, but still it is called as anti-fluoride crystal because what is the arrangement here? It is present in fluoride crystal. Exactly opposite arrangement it is present in anti-fluoride crystal. Exactly opposite. What is meant by opposite? Let us see. Clear ma? So first I will take Na plus and O2 minus. So these are the ions which can be formed. Are you able to understand, ma? So in Ca2 plus what I have? FCC. FCC will be present here. Are you able to understand? And tetrahedral voids are present for anion, no? So here it will be present for cation. So all tetrahedral voids. That's all. Okay. That is why this crystal is called as anti-fluoride crystal. Okay, my exact opposite arrangement to fluoride crystal. Okay. So here cations they are present in FCC, but here anions they are present in FCC. So here anions are present on tetrahedral voids. So here cations are present on tetrahedral voids. And remaining calculation can't you do, ma? Now very easy, do the calculation. Clear? So how many Na plus by mass? Okay, ma? Tetrahedral voids. Tetrahedral voids means how many? 4. 8. So 8 Na plus by mass. Clear, na? Here FCC means 4. So 4O2 minus by mass. So therefore what is the formula unit which we will get? Clear, ma? So formula unit is how much? So 8 Na plus 4O2 minus. If you combine them, what I will get? I will get 4 Na2O. This is what I will get. So therefore number of formula units how many, ma? Number of formula units there are 4. Understood, no? That's all. Clear? Now let us see coordination number. Okay. So Na plus. So where Na plus are present? Tetrahedral voids. If atoms are present on tetrahedral voids, what is the coordination number? 4. So 4. Clear, no? And next which one? O2 minus. Where they are present? FCC. FCC means atoms are present at the coordinates. If atoms are present at the coordinates, what is the coordination number? 8. That's all. This is my answer. Okay, ma? So these are the 4 crystals which you should by heart, ma. Clear? And what is the method in which we have studied? If the same method if you study, then it will be very easy for you. Understood? So don't by heart anything. Just arrangement you have to by heart, ma. Remaining everything you can remember the same method which we have done. Clear? So this completes our chapter called solid state. Equilibrium we will start in the next class. So this is the last topic in solid state, ma. Density of ionic crystal. Okay. So we know that density is equals to mass by volume, no, ma? Density is equal to total mass divided by total volume is called as density. Okay. Now I want to calculate density of this ionic crystal, cubic crystal. So cubes we have studied, many types of cubes we have studied. Like we have studied PCC, primitive cubic cell. We have also studied about FCC, BCC, body centered cubic. So I want to calculate the density of all these crystals. Okay, ma? So we know that 1 molar mass is also called as molecular weight, no, ma? 1 molar mass is also called as molecular weight. Now what is meant by 1 molar mass, ma? What is meant by molecular mass? So it is the mass of 1 mole of atoms or molecules or ions or formula units. That's all, no? So mass of 1 mole of atoms, molecules, ions or formula units is called as molecular weight. Clear, no? That's all, no? Mass of these many atoms, these many molecules, ions or formula units. Now what is meant by 1 mole? Mole is a number, no? So therefore I can write mass of 1 atom or I can write mass of 1 molecule or mass of 1 formula unit, okay, ma, multiplied by Avogadro number. Can I call it as molecular weight? Is it correct, ma? Mole means number, no? Which number? Avogadro number. Clear, no? So mass of 1 single atom or 1 single molecule or 1 formula unit multiplied by how many atoms or molecules or formula units multiplied by 1 Avogadro number, that is also called as molecular weight. Are you able to understand? Okay. Therefore, mass of 1 atom or mass of one molecule. Ions also we can write directly. I am writing mass of one formula unit. Z means formula unit. One formula unit, or just we will write one formula unit. How can I write? I can write molecular weight divided by Na. I can write like this, no? Molecular weight divided by Na. So just this Na I am sending to the other side. Are you able to understand? So until now what we have got? We have got mass of one atom, or mass of one molecule, or mass of one formula unit. NaCl, it will become one formula unit, no? NaCl, CSCl, all of them they will become one formula unit. Clear, number? So therefore mass of one formula unit I can write like this. But in an ionic crystal, how many formula units may be present? That depends upon the type of the unit cell, no? For example, if you say if you take primitive unit cell, in a primitive unit cell, how many formula units will be there? Only one formula unit. What is meant by primitive unit cell? Atoms, they are present only at the corners. How many corners? 8 corners. What is the contribution? 1 by 8. 1 by 8 into 8 is 1. BCC, body centered cubic structure. So 8 atoms are present at the corners, and there is one atom present at the center also. So totally formula unit is 2. Similarly, if you take FCC, 4. So like this, depending upon the type of crystal, Z value will change, no? Clear, no? So in an ionic crystal, Z formula units may be present. Z formula units may be present. Clear, no? For example, I will write for primitive unit cell or primitive cubic cell, Z value is how much? 1. For BCC, it is Z value is equal to 2. For FCC, it is Z value is equal to 4. Clear? Therefore, mass of unit cell, how can I write? Mass of unit cell, how can I write, ma? According to this formula, can you say, how can I write mass of one unit cell? Whatever may be the type of unit cell, PCC, BCC, FCC, how can I write? Anybody? Suppose I am discussing only about mass only. What is this one? This is mass of one formula unit. That's all, no? Or you can say mass of one atom, or you can say mass of one molecule. Okay? Now if I want to write mass of total unit cell, okay, mass of total unit cell I want to write down, then how can you write the equation for mass? Z, that's all. Clear, no? So this is the mass of one unit cell, no? How many unit cells may be there? 1 may be there, 2 may be there, 3 may be there, and more also may be there depending upon the type of unit cell. Clear, no? So therefore mass of one unit cell is Z into mass of one formula unit. What is the mass of one formula unit? Molecular weight divided by Na. So this is the formula. Clear, no? So therefore this is the mass of one unit cell. So if I calculate mass, can't I calculate density, mano? M value I have calculated, no? Volume. So can you say what is the formula for volume of a cubic cell, ma? Volume of a unit cell or a cubic unit cell. Volume of a cubic unit cell. Volume of a cube entara? A cube. Edge length we have taken A, no? So length is A, breadth is also A, depth is also A only. So volume is how much? Volume is A cube. Clear, no? So mass I have calculated, mass of unit cell, and volume of unit cell I have calculated. So density of unit cell, just divide both of them. Okay, ma? So therefore density of unit cell is how much? So this is equals to mass by volume. That's all, ma? What is the mass? Mass is Z into molecular weight divided by Na multiplied by what is the volume? A cube. That's all. This is my formula to calculate density of unit cell. Understood, no, ma? Is it clear how we have understood all this? So Z into molecular weight divided by Avogadro number multiplied by A cube. Okay, ma? So many times questions were given on this relation. Okay? So write down, we will do one question on this, then you will understand. So this is the given question. So edge length of metal having molar mass 75 is 5 angstrom. Clear, no, ma? So therefore edge length means A only, no, ma? A is 5 angstrom. 5 angstrom, how can you write in SI system? 5 into 10 power minus 10 meters. But everything is given in grams per centimeter cube. CGS system is given, no? So 5 into 10 power minus 10 meter will convert into 5 into 10 power minus 8 centimeters. This is how I can write down. Clear, no? Now see. So then edge length is given, then what is the molar mass? Molar mass is nothing but molecular weight is how much? 75. 75 means what? 75 means if you take a single molecule, then it is 75 AMU. If you take mole of atoms or mole of molecules, then it is grams. That's all, number. So molecular weight is 75 grams. Are you able to understand? Okay. Then it is crystallizing into a cubic lattice. So therefore, what is the formula for volume? Cubic lattice, no, volume is A cube, where edge length is A. And density is already given. What is the density of the crystal, ma? Density of the crystal is 2 grams per centimeter cube. This is the density of the crystal. Then you are supposed to find out what is the radius of the metal atom. So what is the radius of each atom which is present inside that crystal that I want to calculate. Anybody? How can I do this? Very good. First you calculate Z value. Clear, nama? Which is the formula I can use? Density is equals to Z into molecular weight divided by Na multiplied by A cube. This is the relation which I can use, nama? Density is already given, no? 2 grams per centimeter cube. Everything we are trying to calculate in CGS system only. So directly you can write a 2 here. How many formula units? I don't know. What is the type of unit cell? I don't know, no? Whether it is PCC, whether it is BCC, whether it is FCC, we don't know. So Z value just you can write like this. What is the molecular weight? 75. And it is given in grams only, no? So no problem. Divided by Avogadro number 6.023 into 10 power 23 multiplied by edge length. Edge length is how much? 5 into 10 power minus 8 whole cube. Are you able to understand, no? So if I do this total calculation, then I will get Z value. Okay, ma? And Z value which you will get is 4. Do you know how I got 4, ma? Without calculation, how can I get 4? How I have written Z value is 4? Anybody, can you say? Nobody? How I know that it is FCC? Huh? He did not give anything about percentages here. Huh? Z is equal to 4, I know, because I know the answer, right? Z value is 4, that's all. Clear? Z value is 4 means this is what kind of unit cell? This is FCC, face-centered cubic unit cell. So once I know Z value, then I can calculate R, no, because in FCC, okay, we have a relation, no, R is equals to A by 2 root 2 angstrom. Do you remember this one? So we have derived relations between radius and edge length in all types of unit cells, no? So in FCC, this is the relation. Do you remember this one? R is equals to A by 2 root 2. Then can't you calculate radius? That's it. So R is equals to, what is A value? 5. So 5 divided by 2 root 2. Just do this calculation. That is the radius of each atom present in this FCC. Understood, Nama? Let me see what is the answer. Congratulations, my answer is not given. So you do this calculation. So R is equals to 5 divided by 2 into root 2 is 1.414. Clear, Nama? 5 divided by 2.828. Do this calculation. That is the radius of this atom. Understood, no?